amazing companies that support the Ruby community. So please visit our event homepage and navigate to /sponsors to check which companies bought you your Kaigi ticket. This might also be a possible list of companies that would not force you to work on the RubyKaigi Day. So you may tell your friends that here's such a list. Okay. Are you ready now? Not yet? Okay. Okay, next. Let me quickly guide you through this lovely venue. We have a parallel tracks running a talk concurrently in each track. The tracks are called track A and track B, or in the virtual world, it's called channels, not actors. Most of the talks in channel A are spoken in Japanese, and all talks in channel B are spoken in English. For non-Japanese speakers who wants to attend track A sessions, we provide the English track as usual. So to sum up, we have 3 tracks, track 1 Japanese, track 1 English version, and track 2 spoken in English. You can switch between the channels anytime, or maybe you can even watch multiple tracks at once, if that works for you. いいかな? T-shirts. You see, I'm wearing a RubyKaigi pizza T-shirt. If you want one, you can take out from a website /novelties or something. If you live inside Japan, you can buy from Suzuri, and whoever else lives outside Japan, you can buy from Shopify. Right? So I think that's everything for me. So the first session kicks off with Koichi's Reactor talk very soon. Please enjoy. Thank you. Okay. Hi. Hello, we're working on reorganizing the channels, and we just changed the English track channel URL. So it has to be written on chats, this YouTube chat, or on our Twitter announcement. So please check the official information if you're watching the English track. Something written on the website is wrong. We're sorry. And it's going to start soon, I believe. Please wait a little bit more.
I'm Sasada with Good-Bad, and my presentation is titled RACTA Report. Originally, the title was Guild Implementation, but the name has been changed recently to RACTA. So this is what I'm going to talk about today. Please communicate with me via Twitter. You can use #RACTA, and I'll try to look at it. If you have any questions, please post together with the hashtag for Ruby conference. If you're joining us from RubyJP, please join me at the #concurrency channel. Now, multi-core and many-core are the norm these days, and Ruby really has to take advantage of these cores. In order to do this, we could use multiple processes for the purpose of programming, but it's actually quite cumbersome to create multi-thread programs. So multi-thread in MRI is actually restricted so that it doesn't execute in parallel. If we remove the restriction and encourage the use of threads, actually thread programming is extremely complicated and difficult. This is a known fact. Multiple threads share the object or the memory, but if we try to access them in parallel, something wrong would happen, which means that we have to provide synchronization. And if you forget to synchronize, we will end up with problems such as data race and race condition. There are many bad problems related to threads. And debugging is extremely difficult because the behavior is non-deterministic. We don't know if the thing that happened before would happen again under the same conditions, which makes debugging of program extremely difficult. Now, RACTA is a thread programming in C. If you want to create RACTA, it's extremely difficult. And I've spent the last couple of months trying to debug, and it's not completed yet. So this is how challenging this effort is. And we don't want to bring that complexity into Ruby programming. It's supposed to be fun. It's better to be able to avoid such trouble. So the purpose is, let's do parallel programming that is simple in Ruby. That's the objective. In order to make this happen, we are proposing a new mechanism, which is a concurrent abstraction similar to ACTA called RACTA. Actually, RACTA already existed in 2016 under the codename Guild. It's been 4 years. It's a very long project. And this time round, I've spoken with Maz, and we're talking about including this in Ruby 3 under the name RACTA. That's why this presentation is titled RACTA. So what is RACTA? I think we can sum up the concept in these 4 points. Multiple actors in an interpreted process, limited object sharing, delineating clearly what can be shared or cannot be shared, and also there is a synchronization through sending each other objects, and also copy and move are available as the programming advances. So these are the characteristics. The details can be found in the branch document. Here, please refer to this URL for details. Now I would like to show you a demonstration. 4-core, 8-thread machine, and 8 CPUs are visible to you right now. This is a top display, and I will use IRB. If you want to create RACTA, you enter racta.new, and as you would do usually, you would run Fibonacci here. It will take a long time, so I'll just set it at 10. But if you try to execute, you get a warning. Why? Because API implementation is not really mature with RAPTA. So this is experimental, and this is why we get the warning. So RACTA has been created, and in the background it's running in parallel, and we can get the result, which is r.take, and you can get the return value, the result of a Fibonacci calculation. So 10th position of Fibonacci is 55. This value has been returned. Now I want to compare this to thread. This program has 4 threads, and Fibonacci 38 is calculated separately. And as you can see from the status of CPU, 4 CPUs below 100%. This is because of the presence of GVL. Only one thread is working at one time. This is why it takes 15 seconds. So although the machine environment is in parallel, it doesn't actually work in parallel. And this is what we have done. This is actually 8, not 4, double the job as before. And at 100%, you can see that 8 jobs can be processed within 6 to 7 seconds. So earlier, when we used thread, 4 jobs took about 16 seconds. Now, 8 jobs in 7 seconds. So if this was 4 jobs, it should be half of this, which means just under 4 seconds. So you can see that we have achieved a good parallelism, and CPU is at 100%. I think you could see that earlier. Going back to my presentation, this is what we can do now with these specific characteristics. And the detailed specs can be found from this link. I don't have enough time to go into details today, but if you're interested, please go to this link. Japanese articles should be published by the time this video is released, so please use that as well. Let's go back to the concepts that I talked about earlier. So parallelism achieved with actor, and there is clear delineation about which objects can be shared or cannot be shared. Basically, most objects cannot be shared. This is what's been determined in order to avoid the safety issue of a threat in relation to sharing. And shareable objects are defined, as you can see on this list, not many. Because of the lack of sharing, we can avoid race condition, and the thread is safe, and the thread programming-related problems do not occur. Shareable objects are mostly VM-related ones, or user programs can lock them explicitly, or synchronization is required. This is how the problem can be avoided. In terms of communication, there are two methods: push versus pull. First of all, we have an actor-like approach. This is sending and receiving. And the passive type approach. This is the pull type, taking as yield. And you can also take return value of argument block or return value from the block that was passed to actor, and also explicitly defined yield can be taken. Why push and pull? Well, in the case of send, destination is known, which means that we know which actor will receive this. And the pull type means that you know the origin of the source. That's why we call it pull type. You specify the source from which you get something. And we also have copy and move, and they can be defined at the time of sending. How do we send the object that cannot be shared? Well, we do deep copy, but it slows things down, so we have another mode called move. This means that the sending can be done very simply and also very fast, but the source actor cannot refer to the object anymore. With this restriction, we can make sending process faster. So these are the two different approaches. I think this is too much detail, so I want to skip some of the information. But actor comes with queue, and also when something's sent to the incoming port, I can receive that, and the incoming port is connected to queue. And as you continue to advance, the queue is actually unlimited, so there is no block when something's sent. It continues to work and receives taken from this queue. If this is empty, then block may happen. So if you use this mechanism, you can do something like this, quite traditional. This is an actor model ring. So send from here to here, and this raptor will send to another raptor, and it will return to the main raptor. This structure can be used very simply. In addition, we also have something called pull-time communication.
Each vector has outgoing port. By yielding here, yield or return value of the block terminated by vector get exposed in outgoing port. Anybody can take these value, and the first one who runs take can get the value. This is how the model works. By using this, you can connect them together just like before. But the difference is, for yield and take, unless someone takes it away, yield gets blocked, and unless it gets yield, takes gets blocked. This is where rendezvous synchronization happens. This describes the similarity between fiber and vector. I'll skip the details. For example, if you have multiple vectors, And in some cases, you want to get the value out of yielded vectors. Vector select can implement something similar to Go language select statement. But this mechanism is not so good yet, because if there are 10,000 vectors, selecting 10,000 vector every time becomes a performance problem. So I want to find a way to register them in event-driven way. If you use this mechanism, it gets ascended like this, and this one can take them. So you can easily create worker queues. Such worker queues can be connected to pipeline, and these boxes are vectors, and they all work in parallel. Each vector has outgoing port and incoming port, and these can be closed. By closing the port, you can tell everyone not to come to this vector. If you send something to the closed port or to take against the closed outgoing port, you see an error. Outside world can detect that such port is closed. You can use take to monitor the life or death of vector. You can use take or select to fetch vector or blocks return value. As for the exceptions within vector that did not get captured, we can use take to propagate the exceptions. Let's say there are 10 worker queues, and if you use select to see them respectively, then you can use select to monitor if each ended with error or not. This use select at the end. You see everything using take. If there's an exception here, then that exception gets propagated here, and that exception gets propagated here. That way, main can know there's an exception happening on W1, so it can stop the program, relaunch the program, or start separate one to replace W1. I wondered which one to choose between actor-based approach and channel-based approach. Thinking about exception handling that I just covered, I preferred actor-based approach, because with actor-based approach, you can issue exception when the recipient is dead in case you use send. Message passing option. I talked about copy and move. This slide talks about shareable object being sent by reference pointer. With vector, you can create vector.new, but this is different from regular proc. If it contains reference to the outer variables, it will be an error. If there are shareable object here, it can be used inside vector, and that is not good. So we make sure that is not possible. There are some minor changes, such as self being changed to vector object, but I believe this can be written in Ruby-like style. Since it is strictly separated between shareable and unshareables, we have some changes on language side. We are adding some spec. If you don't use vector, then it is 100% compatible. But other than main vector, you cannot use global variables nor class variables. You also cannot use shareable object instance. You cannot use unshareable object inside constants. So you have such limitations. You don't have to make changes right away, but if you want to program using multiple vectors, then libraries changes are further required. This means it is not readily available yet. What kind of program can we write using vectors? This is an example of web application server. Let's say there is one vector accepted by another vector that's thrown to the worker queue, and any worker can receive that request and give back response. I think this scenario is possible. May monitor workers and reactors, and once something happens, it can be relaunched. Let's talk about reactor progress. Basic reactor API I talked about are working already, and Ruby apps without reactor also can work as well. If it doesn't work, that means bug, so please let me know. But when it comes to complex application with reactor, there's not enough VM sync yet, so it doesn't work. Existing Ruby API considerations, C extension support, object passing copy and move, performance tunings, etc. They're not perfect yet. So it comes out with the warning, reactor is experimental. But I think it's good enough for you to try it. Now let me talk about performance assessment. When you create, execute, and wait for empty process, reactor, thread, fiber, or proc, how long would that take? If we ran this process 10,000 times, how long will it take? That's shown on this slide. Compared to the process, reactor and thread are way faster orders of magnitude difference. But when you compare those two against fiber, they're way slower than fiber, again showing orders of magnitude difference. But as you can see, reactor speed is almost the same as that of thread. But it takes time to create them, and I want to accelerate the process. I have some ideas. I'm thinking of a way to have fiber-based creation with Ruby 3.1. So things may be improving in terms of the speed. I also made a program to assess prime number to see the performance of parallel processing. Within the range of 2 to the 10th power to 50th power, we detect the surrounding 1,000 prime numbers. This is how it works, programming-wise. When you sequentially write it, it's fine. And that is how it gets written using reactor. This is reactor network diagram. What happened was, against big integers, against Tn, the more reactor you have, the faster it gets to see prime evaluation results. The speed increased by roughly 4 times. I use 4-core, 8-thread machine. You need to have big enough task granularity. Otherwise, it becomes an overhead for reactor, and the performance drops. So I still see some performance challenges. With further tuning, we may be able to accelerate the speed with smaller numbers, but currently the speed is still slow. But if you have big enough task granularity, then performance is quite good. There is potential for better speed. Now we start seeing Ruby program being run in parallel with reactor without thread safety headache. Reactor API is almost ready, but on VM side, implementation is not enough. We are working hard for the target of Ruby 3 release. That's all. Thank you very much.
Good morning. My name is Yosuke Endo with CookPad. I develop Ruby as business. I'm a Ruby committer. December this year will see the release of Ruby 3, which is a new major version. I want to talk about Ruby 3's key function, static type analysis, specifically type inference that I'm working on. Thank you for this opportunity. In the static analysis, we are trying to simplify Ruby programming. Specifically, for example, if we have 42 plus string type error, it should be identified before execution. And if you write 42.t.i, IDE should suggest that this is probably a times block. And also, method documentation should be displayed. These are the ultimate objectives. What's challenging about Ruby 3 is that we are trying to do this without including type annotation in the code. In order to achieve this ultimate goal, we will be delivering 3 different items specific to type. The first one is called RBS, type signature format. Type information is given from outside into Ruby's code. It's a separate language from Ruby. And the second item is type inference function, generating prototype of RBS from our Ruby code without annotation. And I will explain this in detail. And the third item is a type check, making sure that there's alignment between descriptions of RBS and Ruby. In Ruby 3, we will be bundling 1 and 2. Let me explain what we're trying to do through these items. Basically, .rbs explain the API should be bundled. That's the basic assumption. .rbs doesn't need to be coded. From library.rbs and application.rb, you can generate the prototype for .rbs of application. I know that some people want to write .rbs directly, and that's also possible. And this is why we have independent type inference and type checkers. Application.rbs, once it's prepared, then .rb can be entered to test and check the type in order to make sure that there is alignment between .rb and .rbs. Sorbet and Steep, which are in development right now, work as language server protocol server. So by taking advantage of these, we should be able to provide experience of the IDE that I just spoke about. .rbs can enable much more than this. For example, dynamic type test, not static. In order to run Ruby code robustly, maybe this would be useful at the time of testing. So this is experimental development that's going on right now. And when it comes to linter or code formatter like RubyKaigi, basically, it looks at the codes to propose improvement, but by adding type information, the proposal can be even deeper and more meaningful. So this is something that some people are working on right now. RubyMine and TabMine, IDE can use the .rbs information, which means that the development experience will be even more convenient. And in this presentation, I will be specifically talking about type inference. And this is the agenda of the presentation. I'll begin with an explanation about type profiler. And I would like to show you some demonstrations of type profiler and how the profilers would be used. And finally, I want to talk about how much progress we've made so far and what is the future plan. Type Profiler is a tool based on highly advanced analytical technology called abstract interpretation, which means interpret and execute Ruby code at type level. For example, if you look at these 5 lines of a Ruby code, At the end, we are passing 42 for foo method, and usually 42 integer object will be passed. But in the type profiler, only the information about integer is passed, not the number 42. But as you execute, integer 2s will be called, which means that some form of string will be returned, and this information is abstracted and returned. And as you continue to execute, we will be generating events about information about the fact that foo method receives integer and returns the string, and this information can be collected and output in the RBS format. By the way, why is this called a type profiler? Some people ask this question. This is historical. The first version of type profiler was not a static analysis. Ruby code was executed and the observation was done which types were passed and returned. It was a profiling tool. So this name is not meaningful anymore, and it's actually more confusing because people will confuse it with a normal profiler such as a stack prof. Profilers identifying bottlenecks, so we want to change the name. We are looking for new good name, so if you have a proposal, we would like to ask for your support. All the other static analysis tools start with the word S, letter S, so maybe you should begin with S as well. Now, type profiler is very different from other type systems. Let me explain why and what the difference is. The biggest difference is that normal type system is at the infra-procedure level or the method level. But method, parameter, type annotation, without this, you cannot really use this very well. This is a typical example. So there's an argument and .foo method is called, but we don't know what x is. This is especially problematic when .foo method is defined with many irrelevant classes. There are different ways of dealing with this. A typical approach is make the users write the annotation for the method argument. So TypeScript and the Python type suggestions use this approach, but with Ruby, Maz decided, who's a designer, that we should avoid this as much as possible, so we abandoned this approach. The second possible approach is normal type inference used by ML and Haskell. Investigate how the argument is used within a method and identify the type. But this will provide with a lot of restrictions, or the identified type may be too conservative and too inconvenient. So Maz, who's developing the type testing key, tried this approach before, but he decided that it's too difficult to apply this to all of the Ruby codes. So this time round, we have identified this approach of analyzing across multiple methods rather than doing the analysis at the method level. We know that this will provide us with a more powerful analysis, and there's a lot of research being done, but analysis becomes slow, and controlling the analysis is actually difficult, and there are not many prior examples. It's very challenging, but this is something what we're trying to do. Design and implementation of type profiler comes with all sorts of different problems, all the way from theoretical to practical. And we have been talking about this in many meetings before, but it's endless. So I want to skip this and go straight away to the demonstration. So here's the demo. The first one, application of a type profiler to a very simple program called ao.rb. This program is a 3D rendering program to render a picture like what you see to the right. About 300 lines of code, and the result will be output within less than a second if you use type profiler. So this is the part of the output of a type profiler, which was applied to ao.rb. Plus vec, class signature, so XYZ, float field. This means that this is probably a 3D vector class. And you can see the vector calculation methods at the bottom. This demonstration was shown at the Ruby 3 Summit. but it's been some improvements. Before, we were expressing different methods for setter, getter, and instant variable, but now we are combining them together as ADTR.accessor. And this is another example. Class sphere is the model that is rendered. There is a center and just, and this is all put together in a reader. This is just a cosmetic difference, but vec question mark, this is optional type. Before we had a redundant expression called nil class for vec.
We made small improvement on isect below. In the past, expression was quite redundant, true class or false class. Now I improved it to use bool alias instead. The second demo is more about real-world programming example. It's a project called GoodCheck, a customizable linter for Ruby with around 2,000 lines of code. This was developed by Shotaro-san, who developed Steep. The key point of this is that the project already has an attachment of handwritten RBS. I chose this because now I can compare the result inferred by type profiler and the handwritten one that show the intention of the programmer. I improved the analysis time quite drastically, but still it takes slightly less than 30 seconds. It takes time because this project regularly calls many libraries, such as Active Support Concurrent Ruby, CGI, OptPause. And those libraries don't have RBS. So when the type profiler asks for those, it doesn't use RBS. But it needs to load Active Support Ruby code for analysis purposes, thus taking some time. In the future, I hope these libraries will provide RBS so that we can shorten the time for type profiler analysis. If we analyze GoodCheck alone, that can shorten the analysis time. On your left, you see RBS prototype captured by applying type profiler to GoodCheck. On your right, you see partial class responding to RBS written by Shotaro-san. It's basically the same attribute reader. For example, in case of patterns, it's some kind of array. Globes showing some kind of arrays. It's roughly correct. So it's not too bad, so I'm praising myself here. But compared to the handwritten one, mine is quite redundant. For example, inside patterns, with handwritten one, you see simply type alias. Right now, module names used as namespace are all written out. So again, it is quite redundant. And you see some assumption error as well. Inside globe array show extra options. But this means we have inference error. Down below, you see string inferred as an array. This is a wrong guess. It is quite difficult to have perfect assumption. This is the comparison of signature from different class. Besides attribute reader, you have instance method, class method. Keyword mostly matched as well. But when we look at it on granular level, it's not working well. For example, keyword variable receives hash, but it failed to track the elements. That is what you see here. Also, it says keyword sensitive. Keyword argument receives true. We only saw true between type profilers, but the intention of the programmer was to show bool. So these are the difference between the two here. It shows keyword arguments such as scanner, receiving scanner class in strings, but see written library cannot handle type profiler. As a result of that, it comes out as untyped. When the programmer doesn't want you to use the return value, RBS can write a special type called void. But type profiler does not know if the intention of that return value, so the assessment result of the very last formula that got returned comes out here. Though we have such small differences, I think it is basically working well. The third example is real-world library use case. Let me explain to you briefly. I'm experimenting with diffLCS library. This is a major library. It is ranked as number 4 in terms of gem downloads. In case of library, there's no entry point for analyzing type profiler. I wrote a simple test code. I use diffLCS to call diff method. This can serve as the entry point to start type profile, and the analysis ends in 1 second. This is the result of the analysis. I'll skip the details, but method ending with question mark is assumed to return bool. This is not heuristic to say ending with question mark mean bool, but inside of the method can be executed in abstract way using type, and as a result of that, it shows bool. That's all for the demos. Now I will explain how users can use type profiler. Let me go through how type profiler can be used to create .rbs. In order to create .rb for a library, you need to write code as an entry point for analysis, just like I showed you before with diffLCS. You can usually use test case. In case of library or program, there must be a calling called such as goodcheck, so you can use that as an entry point. By using this entry point and run type profiler, then you see .rbs. Unfortunately, however, this may include some wrong guesses like you saw with my previous examples. When you check and you see some errors, those may be difficult for analysis. So unfortunately, you have to handwrite .rb. Partially specified .rbs and entry point combined together can run type profiler again. Then you see mostly correct .rbs as a result. I am in the middle of implementing partially specifying .rbs, but I want to make it by Ruby 3 release. That's all for how to use type profiler. I'm going to write the actual use of them on my website. I have not written anything yet, so I'll try to write something by RubyKaigi. To conclude, let me talk about the recent updates, future plan before and after Ruby 3 release, and conclusion. Recent update includes cosmetics, which was mentioned before, but I also was working on some internal improvements. For example, RBS can use type variables to express container type. In the past, type profiler handled type variable as any untyped. I decided to work full-fledgedly, so now you can handle array and hash methods as well. Also, support for enumerable and enumerator and struct being added as well. Global variables are now supported since that was necessary for good check analysis. I improved flow-sensitive analysis, and I made some improvements and compromises to analysis speed to a reasonable level, so that it works on a realistic time frame. Also fixed many bugs. With regards to my future plans, I want to work on plain Ruby code that does not use metaprogramming too much before Ruby 3 release. To do so, I need to build a functionality to specify partial RBS, as I mentioned before. Writing documents, releasing gem, experimenting in few projects, further improvements to make. These are the things I want to do as much as possible. After Ruby 3 release, I want to support Sinatra application and Rails application eventually. I think I need to have dedicated hand coding for Rails framework. For example, active support concern is almost a Ruby language extension, so we need to support that. Also, active record is super meta feature, so we need to have some burn-in approach. I'm not too confident to give you the super useful features to Rails developers right now, but please go easy on me with longer perspectives. Type Profiler was not built by me alone. It was built through discussions and advice from many people. I won't read out the names here, but I'm thankful for everyone's contribution. Let's wrap up. Development of Type Profiler is taking a long time, but it is progressing steadily towards Ruby 3 release. We are looking for the right name for Type Profiler, so any suggestions are welcome. If you have any questions, please contact me to my Twitter account @mamenta. That's all. Thank you. My name is Urabe. I'm going to give presentation on on-sending methods. Let me introduce myself first. Shohei is my name on GitHub and Twitter. I work for Moneyforward, mainly working on Ruby development. Due to COVID-19, I work from home a lot. Because of that, I'm ranked as second most active Ruby committer as of 2020. I cannot beat the most active committer, unfortunately, but he is contributing more than double the number of commits. But I committed more than others. Especially, I beat Invincible Matspot, and that makes me very happy. Let's go into the main topic. Let me share my motivation first. I'm working on Ruby speed acceleration with my job right now. Everything started last year. I was profiling Ruby using Discourse benchmark, Rails application to find bottlenecks. This is my tweet. I'm saying VM call ISAC setup being slow. This is the enlarged results of such profiling. I captured the data again for this presentation, so there are minor differences in numbers compared to the previous screen, but the overall trend is the same. The top VM exec core is the main loop in Ruby, so it's natural to see this taking the longest time. But the second one is VM call ISAC setup function, and this one coming as the second doesn't make sense. This is wrong. It was only me, Sasada-san, and Kokubu-san who immediately spotted the problem by simply looking at the profile. So this is quite a deep core discussion, so let me explain what's wrong with this. So what is VM call ISAC setup? It's not too clear. This is TAC jump tool called global. This one, global. You see the search result of VM call ISAC setup, but it's only in 3 locations. So to give you the answer right away, VM call ISAC setup sets up VM stack frame right at the moment when a method is about to run. It's creating stack frame. This function is not designed to be called frequently because there is a purpose-built implementation separately. So usually, inline method cache is being used. When there is a cache mishit, VM call ISAC setup comes into play. Behavior of inline method cache is important, so let me deep dive on that here. Let's think about the simple method. When we interpret the previous method definition, this instruction sequence comes up. Put self, leave instruction have not much to do with method cache discussion. The issue is opt send without block instruction. This is the implementation. It's quite short, and most of the process is done within VM sendish. Let's refer to that one. This one? It's quite long, so let's scroll down. Here, you see CC arrow call indirect reference. This is inline method cache. So this is the inline method cache data structure, struct RB call cache. When you hit method state, class serial, hit the key. There are 2 keys. When you hit those 2, function pointer named call will be used. Which function does CC arrow call point to? That's the next question. When you read the source code, you see setting within CC set fast path macro. So you can use this for search purposes. When you go and do global search, you see lots of them. On the second line, you see VM call ISEC setup. This is the function that we were looking for. When you look back, you see it gets called by huge switch within VM call method each type. This function is obviously not specialized. Next question is, where is this VM call method each type function called from? It comes from VM call method function. As you can see from the name, method visit public or method visit private. This is the function that is checking for the visibility. Again, where is this one called from? This one, VM call general. The name suggests that this one is not specialized. This VM call general is assigned to CCRO call. That's within the RB VM search method slow path function. Comes from VM search method. You see cache hit on few lines above. Right after cache hit, it returns. In the if statement, you see cache hit. If not, there's no hit. So this is where the problem resides. In short, VM call ISEC setup is assigned to CCRO call when inline method cache mishit happens. This function shows up as second most frequent operation in profiler output, means cache mishit happens very frequently. This is, of course, not by design. Let's check cache hit rate. In the previous slide, cache hit rate counter was shown. Have you noticed that? You see debug counter, hit and miss. These two arrows. These were implemented by Sasada-san in the past. You can enable that, and then run discourse script /bench RB, you see the following output. So there are so many of them. You need to find the one that you're looking for. Right here. 2 lines nearly at the top. When you run the calculation, the result is coming out as 982 million over 1.022 billion. That means 90.8%. The hit rate is too low. Let's look at the original design of inline method cache. This proceedings was written by Sasada-san in 2004. This is a grant paper for Mito Software Creative Project led by Ministry of Economy, Trade and Industry. This paper is called Method Caching Methodology for Ruby. On table 2, original proposal was aiming at much higher cache hit rate, big numbers like 98%, 97%. Our inline method cache mechanism is not working as intended. I'm done with the long introduction part. Now let's look at more detailed investigation. Now we know we have frequent cache mishits. We don't know why though. In order to fix it, we have to know what exactly is going on when a cache mishits. So we can run simple printf debug. As soon as we go into VM call ISEC setup, we run printf to show where it gets called from. This function is in the middle of calling method. So if you call different method within this function, it becomes recursive permanently. So we have to be careful to avoid Ruby method calling, but we get to show where it gets called from. When you run it, you see lots of them. You need to run sort unique sort. You read all the outputs quickly. One thing you notice then is there's no cache of read attribute method. Topic or user or app model defined by discourse, but there's no cache for method calling. Also, on file side, active report, attribute methods, read RB comes out a lot. Sometimes it comes out as pair with read attributes, the other time it's not. You can guess something is happening on specific portion of active record. So we go see it on GitHub. Fortunately, the file is not so big, so you can read it through. You can see read attribute being implemented. This method changes the given name after name slightly, and then call read attribute, and the read under attribute is written beneath. After running the processes, it calls for fetch value. The 39th row, going back to the note, is the top hit one. So the file shown here is where the problem resides.
Active record attribute method read is a module. This is included from Rails application model class, so this read attribute method implementation is shared by several classes. This is what it looks like as a graph. User, post, topic are the model classes and inherits the active record base. Active record base includes attribute methods module, and that in turn includes the read module. Read module includes read attribute and underscore read attribute methods, and read attribute calls the underscore read attribute. Let's go back to inline method cache. The cache determination only looks at class of. The comparison is only made once here with equal equal. Even if user and topic share the same method, from inline method cache's perspective, it will think that the class is different, therefore a different method. This is the actual cache mishit scenario. First, user's read attribute is called. When underscore read attribute is called, user's underscore read attribute is cached. When post read attribute is called from elsewhere, when underscore read attribute is called already, the cached user underscore read attribute is evicted, and instead the post underscore read attribute is cached. When user read attribute is called again later, post underscore read attribute is evicted this time, and user underscore read attribute is cached. That's how it goes. Okay, that was wordy. Now that we finally understand the problem, let's try to fix this. So let's go back to the problem. Inline method cache mishits too often. This happens when one method is shared by several classes. This is caused by inheritance and/or module inclusion. How should we fix this? Should we trace back the class hierarchy to check that a same thing is indeed a same thing? This won't work because of refinements in Ruby. Even for the same class or two classes that's inherited, methods with the same name may not have the same definition. Also, scanning inheritance is too heavy, so it's not suitable for cache hit determination. Because of the nature of cache hit determination, it needs to be completed promptly. It shouldn't take time. So we can't scan the inheritance point by point. So let's forget the class hierarchy for now, and instead keep in mind the class and method tuple. This is the new design. So far, inline method cache only cached one method in a class. This time, we'll apply this to a case when multiple classes have same method body, so multiple classes will be held in one method cache. Sasada-san pointed out to me that this is close to polymorphic inline caching. The details are included in the paper that I've introduced here. But Sasada-san pointed this out after I was done with my work. So the technique I've used is not completely identical. It just so ended up being similar. But if you take a look at it closely, the content is quite different. This is the tweet that pointed this out. I had no idea about the similarity. This was inefficient. I shouldn't have reinvented the wheel. Once the issue was uncovered, I knew that I could fix it, and I did, but I should have looked for existing solution instead of diving right into finding a solution on my own. I've learned my lesson. So, how did I fix this specifically? So this is struct RB call cache again. There's only one class serial stored with one unique serial number. I've expanded the struct so that it could hold multiple serials. This is the diff of that part. There's a size of that's running a complex calculation. It's adjusting the array size to fit the struct into the cache line. The technique is tricky and important, but not the most important point. The main point to highlight is that there's one negative line taken out and an array is created instead. Next, in VM search method fast path, serial is compared here with a single equal. VM cache check for class serial function is created newly to make the comparison instead. This is the implementation of that function. It's a bit long. For statement is here. This one. And class serial is scanned. If there's a hit, then it returns true. So that was the implementation. So that's all of the implementation. Next, let's take a look at how much improvement was made. Like before, the result is taken from this course's script /bench_rb. Our area of concern was cache hit rate. It went up by about 5% from 90.8% to 95.06%. The original assumption was 98% hit, so it's still low compared to that, but improvement has been made. Next is the profiling result that I've shown you in the beginning. The problem was uncovered with this originally. What's shown right now is the original profile, but this changed to this. VM call ISEC setup came down. VM call cfunc and the VM call ISEC setup normal 0 start 0 parameter 0 locals. The more specialized versions have come up instead. This proves the improvement in cache hit rate. The previous animation is hard to see. Perf command has diff subcommand, so here's the diff. As you can see, RBID table lookup, this one, method entry get, and RBVM search method slow path. These have a large negative delta. These are the method search-related routines. If inline method cache hits, these will be and should be skipped. So it's running as one assumes they would. Lastly, this is the benchmark taken when a request was sent to HTTP. The response time is collected from the log, and this is the resulting histogram. Blue is before and orange is after proposed solution. Overall, the proposed solution shifts the histogram peak to the left, especially the mode value shifts to the left significantly, like this. The minimum value, this one hasn't changed so much. See that? If the cache is hit for both, there is no difference. But when cache mishit decreases, the overhead improves. That's what we can deduce from this. So let's sum this up. In terms of quantitative improvements, cache hit rate improved from 90.8% to 95.06%. The response time median decreased from 70 milliseconds to 69 milliseconds, and the response time mode improved from 69 milliseconds to 67 milliseconds. The profiler no longer considers VM call ISEC setup as the hotspot. Specialized functions have come up higher. Conclusion. In the area where the method search result is cached in the interpreter, I found some parts that's not running well with inheritance. It typically happens in Rails. I fixed this by accepting multiple classes per cache key. This improved cache hit rate and Rails performance as well. So this pull request 2583, this has successfully been merged. So it's been included in Ruby Master already. It's been merged last year, so it's already included in 2.7. So if you're still using 2.6, then just by upgrading to Ruby 2.7, you will be able to gain performance improvement from today. Yay. So I hope you'll give it a shot today. Great, great. So I want to talk a bit about the future. Pull request 2888. The problem child RB call cache is taken out. It's gone. The inline method cache mechanism was entirely rewritten by Sasada-san after the release of 2.7. Ractor, which was called Guild in the past, didn't work well with conventional cache. Multiple Ractors could cache something at the same time, so this needed to be redesigned atomically to avoid breaking it. And the redesign does not take into consideration the things that I talked about today. So according to Sasada-san, 2.8 is lower than 2.7, so he says. Unfortunately, I didn't have time to check this myself, so I only heard about this from Sasada-san. So, a sliver of possibility remains that Ruby 2.7 was actually the fastest Ruby on record. We need to work hard to make Ruby faster from here on. But can we do that by re-implementing what we discussed today? No. Copy and paste won't work. The data structure has changed, so it needs to be rewritten. The concept can be used, but it needs to be re-implemented. So try Ruby 2.7. It's fast. You'll love it. That's it from me. Thank you for your attention.
Konnichiwa.
Hello, I'm Yo-chan. My name is Osaki Yo. Today, I'd like to talk about asynchronous OPAL. So, this is more like a live coding rather than a talk. And I thought I would explain the background, but the live coding went quite extensive, and thus I had to cut that part. So if you are interested in learning the background, please visit last year's Ruby World Conference, where Samuel Williams gave the presentation on asynchronous Ruby. And there is a video still available for you. And I heard his presentation and I thought that it would be nice to have a function like asynchronous Ruby for OPAL as well, and thus I'm developing. OPAL is a compiler that converts from Ruby to JavaScript. So as for the language, it uses Ruby, but the execution environment is JavaScript. The asynchronous part also utilizes the JavaScript function. And JavaScript asynchronous state has been evolved from callback, promise, and async wait. And this async wait is a function which started from ECMAScript 6, and it changes the syntax of the language. So it's quite difficult to follow that with OPAL because we can't change the Ruby's syntax. So the idea came up to me that I should use the interface similar to asynchronous RB and insert code conversion to a specific call. That's how I wanted to materialize this. So let me show you the live coding to explain the specific contents. And this is recorded version, so it's not live, but let's call it live coding. So, OPAL, I would like to make async usable. Here, OPAL source code is checked out. And you see a gem file here. This is the source code OPAL to be executable. So first of all, I would like to write what would happen if I write with promise. In order to use promise, you send require. And I want to write the asynchronous process. It would be nice if I could use network access, but let's think simple. So I am going to make a sleep leveraging set timeout. And when I execute this code, start and end are called, and in 3 seconds, hello promise is output. Now, the asynchronous process was written under promise. Now, let's make this promise-based code to be async. This sleep method shall be kept as is, and the portion where we are calling with promise should be changed in a format that we could call with the JavaScript syncout. So let's define the formula. And in here, we call this sleep, but here we call the async method. And in this block, this shall be the async portion. Inside of here, it is written to call the promises then, but in order to make it understandable, this is a continuous process. Instead of calling then, I would like to write this manner, and I would like to continue writing in this manner, but this will continue to be asynchronous, so we use the keyword await. And under this state, this will be an ordinary method call, and it's rather difficult to understand where the await is applied to, so we call this over the block. Now, async and await code are written. This would be an ideal way to write this code. So I would like to change the code in this manner. And let me explain this code. Here you see async. So once you call here, inside of this block will become asynchronous process. This is asynchronous process, therefore, the return value of this call would be similar to sleep, and thus it will return the promise. The await side, inside of this block, as long as this is asynchronously processed, here, if the call of asynchronous is made, this will go out from asynchronous, and this, once it comes back, it will continue to process. So let's see the installation of the async. This is the method to return the promise. So let's define this. Opal has a standard library like this. These codes exist, and promise is here as well. And make a file called async here. Async method is called by the top level. So let's define this as a kernel module method. Async. As explained earlier, this is the method to return the promise. Since it uses promise, let's write require here. And async receives a block, so we have to call yield. This yield call if you pass it as the argument of promise is resolved, the result of the block execution will be passed as an argument when the promise then method is executed. Now async method is accomplished. So let's execute the code that I wrote earlier. Done. Yeah. Why I was able to execute this? Well, I have not called the async func yet. So let's see the result. Async func is supposed to be returning promise, and this await is unusable. So let's comment out this for the moment, and I was missing require here. Now I was able to execute. Promise was returned. So Let's install the await. Actually, this is a real performance. As explained earlier, the code conversion is required here. Well, the type of the code conversion we do here, well, let's comment out this for a moment. And this code, this shall return to sleep, but here you see promise, so I would like to rewrite this code using then. And when you rewrite, there's a opal function called rewriter, so we are going to leverage this to install.
In Opal, under lib, there's rewriters. There are a lot of patterns of rewriters included here. For example, this is the for rewriter. It takes for statement. This is the for rewriter. The content is a bit complex, and there are so many S parentheses. This is called the S expression. In Opal, this syntax tree, the AST, is written with S expression. It's true for C Ruby as well. Let's try to create the async rewriter. So first, the rewriter. Let's write this by referring to for rewriter. Let's copy this. End, end, end. Here's async. For rewriter, on for method is defined. For async, I want to rewrite this block async do. Instead of on for, on block will be used. So I need to write what goes in here. To do that, first, I will look into what kind of AST is created and received. Let's try running this code. So many things are popping up, but there should be a line using async. Yes, here it is, like this. In async, this send nil async is here. This is S expression. This node has children inside. The first is the receiver. Second is the arguments. Third is the body. I'll fetch this. And when the first receiver calls async, Then this will be rewritten. Let's take a look at this again. The node is this block. There are children of that. First is the receiver, second is the argument, and third is the body. If there are multiple things inside the body, the process begins with begin. That's the tree structure. So, the question is if the body is a begin, whether the body type is begin or not will determine if this forks or not. If it's begin, then take the body and children. Then, whether there is a begin or not, it doesn't matter. It seems as if there's something in the body. Next, I'll talk about the rewriters. First, let's take a look at the behavior of the rewrite. Initially, with this begin, there were two bodies. But after converting this, the put code is also placed inside this block. So as a tree, there's only one. That's why it looks like this. This is the conversion. First, this await goes away. After sleep, then is called. It's called with a send. This then will go inside the block. So the block comes to the front. There is no block argument. This is the same as here, the same as above. So how does this rewrite turn out to be? It's read from the top. If the rest of the things are all placed inside, it looks as if it becomes one, so it's hard to write the loop here. So the rewritten line should be turned into an array. And let's bring the original body here. Perhaps it doesn't have to be original. So this is the loop. I'll write a while loop. The body. No, I need a different variable. If the original length is more than 0, it will continue to loop.
オリジナルのをシフトしながら
So this code will be read while shifting the original
したい
code.
んですけど、これ
Well,
が
I want to
こ
shift
の
this,
子が
but this one,
とフローズンなオブ
this
ジェ
here
クトなので
is a frozen
フ
object.
ァーストを取って
So I'll fetch the first
中身を入れ替えちゃう。
and swap the contents.
スライスの
This slice
1から。
from 1 to the end.
でこれで残りを表しています。
This expresses the rest.
で、今何を書いてるかという
So
と、
what am I writing now? Not here.
この書き換えをしたいんですけれど、
I want to
ここが
rewrite this
await だった
bit.
時に
If there is an await block here, I will make it so that a rewrite occurs.
アウェイトのブロックなので、まずブロック
This is an await block, so I'll first check to see if this is a block or
ダ
not,
チャイルド
and then take a look at its child.
使わない。
I won't use the argument.
この
Body.
ノードのチルドレンを見て、
I'll take a look at this
この
node's
レシーバー
children.
はさっきと同じようなコード
This receiver, the code is similar to the one we've seen before,
同じような感じ
like this one.
ブロックの中にあって、
So it's inside the block.
ここがアウェイトなやつ。
The await is here.
っていうコードになります。
So that's what the code will look like.
で、この時に書き換えをし
So
ない
when it's like this, it needs to be rewritten.
なので、
So,
リライトに
so inside
書き換えたものが入る。
rewritten, something that has been rewritten will come.
で、ここで書き換えたら、
Once it's rewritten here,
はブロック
what follows
前の後のブロックの
will go
全部
inside the
入れてしまう
block
の
after
で
then.
抜けます。
So that's the end.
ここはブレイクしちゃいましょ
Well, let's break here.
う。で、リライト
Rewritten.
に、ノードをそのままに。
And the node will be placed here as is.
で、ここの書き換えをどういう書き換えをするかという
So,
と、
how is this rewritten?
こんな感じですね。
Like this.
と、このここがアウェイトの中のブロックの中のボディです。
This is the body inside the block of await.
前を呼ぶよ
So
う
the
な
body within the block will call then.
あれsend
Send,
い
body, then.
ね。で、その外側にブロック
Outside,
ですね。
there's a block.
これは前に渡すブロック。
So this is the block to hand over to then.
引数はなしなので、こんな感じ。
There's no argument, so it will be written like this.
で、その次に、
Next,
このブロックのアーグスが
this block's argument.
違う。ブロ
No,
ックはこうなるのかな。
this is how this block needs to be written.
アーグス、ち
Argument.
ょっと読みにくいので、ちょっとインデントさせましょ
I'll indent to make it easier to read.
う。これの一個内側ですね。
Indent this inside.
で、アーグスの次に来るのが、
So what comes after the argument?
と、 この後続の処理を
The process that
ブロック
follows
の中身として渡したい
needs to be
ので
handed over as the content of this
ここ
block.
で残ってる
So
オリジナルを渡してあげ
the
る
remaining original
ことになります。
will be handed over.
ただし、このオリジナルってい
But
うのは配列で来るの
this
で
original will
S 式
come
に
as an
変換してあげ
array,
なければ
so it needs to be converted to S
な
expression.
ので、
So
で、実はこのリライトボディも、
actually, the rewrite
ライ
body
トを
here
返すみたいなことにし
needs to be returned.
ここでも
So
エクストラクトしてあげる必要が
I need an extract here.
っていうコードで、
So this is the code.
コードのこれをこっちですね。
This one.
を実行してあげると、
When this code is executed,
はい、書き換えた後と同じ
so the code is quite similar to the one after it's been rewritten,
こんな感じですね。
just like this.
で、このように、async 非同期関数の中身を書き
By
換え
rewriting the
ることに
content
よ
of
って
async, the asynchronous function, the execution order will be under control.
プロミスを使った呼び出しと同じように書き
It's
換えて
rewritten so that the end result will be similar to a call using promise.
async await が
So this is how I executed upon the idea of realizing async await with
実
Opal.
際にやってみました。
Good afternoon, I'm Sudo. So today I'm going to talk about fat gems. I am a CEO of ClearCode. ClearCode is silver sponsor of RubyKaigi 2020. In relation to Ruby, in relation to what I'm going to talk about today, is I am a maintainer of the Relic compiler, which is gem for generating the fat gem, and also I'm maintaining the generic ROM. And the fat gem, let me explain what it is. What gem is pre-built binary including gems. Why do we need the fat gems? Let me explain the background. Ruby has a C API-based implemented Ruby library called extension library, but it is difficult to build the extension library. In order to solve this matter, fat gem was born. Fat gem is the copies per build libraries, so you can just copy it. Why is it that difficult to build the extension library? Well, most of them are written in C, then not only Ruby environment, but C environment, and MKMS Ruby library exists. That is a standard library. But often case you'd use that, and you need a make if you use that. So different environment needs to be prepared. That is a difficulty. And the extension library, if that requires external library, that library needs to be prepared. That made the build so complicated. With fat gem, what would happen? Users don't need to build the environment. So people do not have to give up because of the difficulty of building the environment, and also you don't fail the installation because the pre-built binary needs to be copied. That's it. So you won't fail. Therefore, with fat gem, you think you'd be happy. Well, sometimes, yes, it was the case that we made you happy, but there are issues came up in relation to this, so I am going to share that story with you. So I have been maintaining the fat gems to date, and what I feel now is that there has been time that we really thanks to fat gem, but I think it is almost the time to say goodbye. There are several issues around fat gem. Let me explain. The first one is that it won't allow you to utilize a recent Ruby. So Ruby is released at every Christmas. So to use the fat gems with the latest version, the fat gem build for the latest Ruby needs to be released. And the users must have everything comparable to the latest Ruby in order to utilize that system. So from the maintenance standpoint, Ruby is being released, the newest version is released at Christmas, but not necessarily all the gems are comparable to the latest version of Ruby immediately. We can't do it immediately. So sometimes we need to ask to be upgraded after the new year. So not all fat gems are not relevant to the latest Ruby, but which means that user will not be able to utilize it. There will be some time lag, but that has to be accepted. From the maintenance standpoint, there's another problem of fat gem. vulnerability response seems to be slower. Let me explain what it is. So, there's the external library, extension library, and the issue happens from here. So, what gems must include all the external library binary, not only internal one, but external library binary are included. So this external library might have vulnerability. Then the fixed version needs to be built and the fat gem needs to be released. And of course, that cannot be done immediately. The vulnerability information is quite a sensitive matter. It has to be handled in sensitive manner. So external libraries release cannot be immediately shared with the external person. So the binding developers will sometimes know the existence of vulnerability when the release is released. And then they start the reactions for the vulnerabilities. So it has to be, or it is normal to have some time lag from maintenance standpoint. There's another problem. We cannot control the external libraries versions. This is unique to the binding. When we create FATGEM, we don't create different ones for each external library, but we only make one to support one library version. So the maintainer, if the maintainer is choosing the old version of external library, the users may not be able to utilize the latest version. With the latest version, a certain problem was fixed, but the FATGEM bundled binary is still on the old version. If that is the case, user cannot leverage the latest version. The next problem is the slowdown of the require. The FATGEM's require is like this code. What it does is reads the binary for the FATGEM if there is one. If not, build your own binary and read it. Why does this make the require slower? In the environment without FATGEM, the require fails. The first one always fails. The FATGEM pre-built binary require always fail. FATGEM is created for the environment when the users have difficulty to build the environment. So most of the case, it is built for the Windows. So for other environments such as Web Linux or macOS environment, the FATGEM require always fail. So non-Windows environment with many paths in load path, the time to fail the initial require becomes quite long. In the case reported to the I/O console, when there is a large load path on Ruby on Rails, one require takes 0.1 seconds to fail. That is one of the report we found. So each FATGEM spans 0.1 seconds. If there are 10 FATGEMs, 1 second slowdown, which is noticeable. And the next FATGEM problem, people forget the FATGEM releases. Normal gem release is relatively easy. Bandra and others issues for the gem release, so rake release can be done in a few seconds. However, fat gem release is not that easy. When rake compiler or rake compiler dock is used that I'm developing, it will make it easier, but it will still take more than a few seconds. You will need to reboot, so it might take a few minutes. From the fat gem maintenance viewpoint, because fat gem release is very difficult, we are demotivated to release new versions. In case of Ruby GNOME, more than 10 related gems exist, so it would take approximately 30 minutes to build the release if everything goes well, but things don't go well, so it could take several hours or days to build it. Then the release becomes quite annoying. When we're maintaining both fat gem and normal gem, we forget about the fat gem release because the release level is different by gems. We forgot the IO console 0.4.8 release, but we feel it natural as we maintain the gems. Another problem is the high maintenance cost, especially with the binding fat gem case. Normally, the cross-compiling is used to build the fat gem. It is done on Windows or Linux environment.
Many external libraries do not usually cross-compile, which means that external libraries will have to be provided as binary, and this is how it has to be compiled. If you upgrade the external library, very often we find problems. For example, with the Ruby GNOME I was looking at, there were more than 10 external libraries. When you try to upgrade the version of those libraries, you would almost always fail the build with multiple cores. Every time you upgrade the version and release, you had to send the batch to all of these external libraries. And it took maybe several hours as part of the release. And I was really feeling that this is really high maintenance cost. In order to solve this problem, my proposal is stop using fat gem. Why did we need fat gem in the first place? Well, the users didn't have a build environment. We had to prepare some kind of environment because that was what's stopping the users from installing. And this situation mostly applied to Windows users. But the build environment of recent Windows users has changed. You can use Ruby installer for Windows. And you can use install Ruby on Windows. I think that's most of the people. I know that there are some exceptions, but I know that majority of the people are using this Ruby installer. And the way it was made is different. There's a version that supports Ruby 2.4, and default technology is now supported. Ruby 2.3 reached EOL several years ago, same with 2.4, which means that most of the people are using Ruby installer of 2.4 or later, which means that majority of the Ruby users now have an environment for build already.
Now, 2 years ago, in 2018, Ruby GNOME stopped providing FATGEM. Does it mean that more people are failing the install? The answer is no. FATGEM was introduced to make installation easier, but without FATGEM, installation is not necessarily more complicated. So how are we solving the problems related to FATGEM? And I want to talk about the details. First of all, not being able to use the latest version of Ruby immediately. When the new Ruby is released, actually you don't have to do anything with gem, as long as Ruby C API doesn't change. Even if Ruby C API changes, we can use CI and go to the preview version of the pre-release version of Ruby. You can use that very easily, which means that you can use the correct Ruby and identify the changes to C API before the release, so that you can release the gem before the Ruby version is officially released. You don't need to panic and do something after the release of Ruby like you used to, making the development easier. We can also solve vulnerability-related issues. This is an example of a binding gem case. If you use FATGEM, you had to work on the library, external library that the binding was depending on. But if you don't use FATGEM, you'd be using external libraries stored in the system. And the packaging system is properly managed usually, so they can take care of the vulnerability, which means that gem maintainers don't have to do anything anymore. In many cases, more people are maintaining package system than the number of people who are maintaining FATGEM. Response is faster. It's easier for the users and also those who are maintaining FATGEM. Everybody's happy. And you can solve the problem of version control of user version libraries. Packaging browser will continue to provide the latest versions, so we can use the latest version. Even if it's not that's not the case, the users can install their desired version. And the require doesn't take any longer. What's great is that we will not assume that FATGEM exists. So you'll just try FATGEM once, and you don't have to do that and then go to gem install require anymore. You just do the installation. There's no failure and there's no delay. And this is the reason why Big Decimal abandoned FATGEM. Maintenance is also easier. And you will not forget to release FATGEM because you will not be releasing FATGEM in the first place. Cross-compiling is not necessary, so no need to use Rake compiler or other cross-compiling support tools. And less time is needed because you don't need to do the maintenance of cross-compiling. If you stop using FATGEM, you can resolve all of these FATGEM-related problems. You can also optimize based on the user's environment and increase the speed. Does it mean that everybody will be happy if we stop using FATGEM? Not necessarily, so let's talk about the exceptions. One of the problems of removing FATGEM is longer install time. FATGEM was taking care of this installation time. In other words, it was doing the build in advance. It didn't slow the installation down. But if each user has to do the build, it will take additional time. It really depends on the size of the library. If it's a small system, maybe you will not notice. But if it's a big one, you will notice that the installation will take much longer. I don't know how to solve this problem. I wonder if there's a good idea out there. Another problem is sometimes you may fail with the install, mostly in the case of bindings. Bindings depend on external libraries. The process is not completed within bindings alone. External library has to be installed in advance, otherwise gem install will fail. In order to install our magic, for example, image magic has to be there. Without that, you will fail the gem install. How do we solve this problem? If you automatically install external library, you can solve this problem. Ruby installer for Windows actually has this mechanism. You just specify, please install this package, including this library, in the gem metadata, and it will basically automatically install it at the time of gem install. So with this, you will not fail the install because of the lack of library. Another example. This is a native package installer. This is something that I have created. You can use this and also package config and functionalities to identify the packages in the system. And if the package does not exist, you can always use the system packaging system in order to install the necessary packages. And you can write the code this way. And next conf rd is this example. There is another problem. Sometimes the bundler cannot really resolve the dependency issues. This is a case that was reported in Rails. Bundler used wrong dependency information. In other words, it used the information from FatGem and failed to update the bundle. And this is the kind of error you would see in this case. I think it's a little bit too detailed, so I would like to skip this. But I have actually fixed this already, so that's the solution. As you can see, when I identify a problem, I try to fix the problem itself rather than finding a workaround. This is my development style. And if you agree, if you like this approach of fixing the problems themselves, I suggest that you consider working at a great company called ClearCode. You'll be able to do this at work. Now, this correction should be enabled with Bundler 2.2.0 and after. So once this version is released, you don't have to do anything. As long as you use a new bundler, the problem will be solved. A quick wrap-up of today's presentation. FatGem was really useful up to Ruby 2.3. But now we have a better build environment in Windows. These days, we no longer need to use FatGem. That is the current status. So let's say thank you, FatGem, for everything, and goodbye, FatGem. My message to you today was let's stop using FatGem. So let's stop using FatGem. Thank you for your attention.
Hello, and welcome to my talk, Don't Wait for Me, Scalable Concurrency for Ruby 3. Today we are going to talk about Ruby scalability, what it is, and how it impacts your applications. Then we are going to look at the new Ruby Fiber Scheduler, how it is implemented, and how it can improve existing applications with minimal changes. So, what makes Ruby a great language? Ruby has many good qualities, but I wanted to know what other people thought. So naturally, I asked Twitter, and here are the results. Syntax was the most important, followed by semantics, libraries, and finally, scalability. Someone also voted for Mats. Thank you, Mats, for creating Ruby and supporting my work. So looking at these results, we might wonder, is scalability important? Why did it come last? Many companies are handling large amounts of traffic with Ruby, and yet it looks like scalability might be a weak point. Before we go any further, we should discuss what is scalability, so we have a clear idea of the problems we are trying to solve and how we can make Ruby better in this regard. Scalability is fundamentally about the efficiency of a system and how many resources are required as the size of the problem increases. Even on this slide, we can compare the efficiency of two systems, English and Kanji. English requires 6 times more characters to say the same thing, which is less efficient. So, as we increase the size of our system, efficiency issues manifest in many different ways. One big issue is resource utilization, how much time we spend processing versus waiting. If we do not efficiently utilize the hardware, our scalability will be worse and our running costs will be higher. Cloud providers love it when you build inefficient systems because they make lots of money. But we want to avoid this situation to make our business growth more cost-effective. Modern processors are so fast that they often spend a lot of time waiting on memory, storage, and network I/O. In order to utilize the hardware more efficiently, we can timeshare between multiple tasks. When one task is waiting, another can execute. This is one way to improve scalability. Typical operating systems use processors and threads to execute tasks. Threads are very similar to processors, but they have reduced isolation and fault tolerance because they share memory and address space. A single hardware processor can context switch between these tasks in order to complete all the required work as quickly as possible. We can add more hardware processors to increase the scale of a system. This allows multiple tasks to execute simultaneously. In the case that one task is waiting, the processor can move to another task. But shifting between tasks is not free. Context switching, as it's called, is a relatively expensive operation at the system level, and as processors dance around between tasks, the overhead of switching can become significant. We refer to this simultaneous execution as parallelism, and it is an important part of any scalable system. However, it also introduces significant complexities, including non-determinism, race conditions, and fault tolerance. Application code should not need to deal with these complexities, and it has been shown time and time again that thread safety issues are a significant source of bugs. But when used carefully, isolated parallelism provides the foundation for scalable systems. Another way to improve hardware utilization is to interleave tasks. There are several ways to do this: callbacks, promises, and fibers. When the application code would execute a blocking operation, the state is saved. Instead of waiting, some other task will be executed. And when the application code is ready to process again, it will be resumed. This allows us to combine tasks back to back in a single process. We can minimize the system-level context switch overhead by implementing an event loop which can schedule work more efficiently. We refer to this interleaved execution as concurrency, and it is an important tool for highly scalable systems. Threads and processes are designed to expose hardware-level parallelism, which is typically limited by the number of processor cores in your system. In practice, process or thread per connection implies an upper bound of 10 to 100 connections per system, which is simply not practical if you want to build highly scalable applications. How does scalability impact cost? A lack of scalability in an application can cost the business. Not only does it increase your hardware cost, but it can impact your user experience if systems become overloaded. In addition, you may find you are building more complex distributed systems to account for a lack of scalability in your core application. These designs bring many hidden costs, including operational and maintenance overheads, and make it hard to move on new opportunities because of scalability debt. Efficient, scalable systems are great for the planet. Less computers are required for the same work. The technology sector is responsible for about 2% of global carbon emissions, and as a civilization, we are facing an unprecedented set of challenges relating to climate change. We can help by improving the scalability of our code to reduce natural resource consumption and energy utilization. Our code can help to build more efficient systems for society. I believe this is our responsibility as software engineers. Is Ruby fast enough? A huge amount of effort goes into Ruby, including significant improvements to the interpreter, garbage collection, and just-in-time compilation. Yet we are still trying to improve performance. Let's consider this hypothetical request, which includes several blocking operations. I have split it into 10 milliseconds of processing time and 190 milliseconds of waiting time. The total time is 200 milliseconds. This is a very typical situation. Here is an example of a real Ruby web application which has a similar profile. At its peak, 25 milliseconds is spent executing Ruby code, and 150 milliseconds is spent waiting on Redis and external HTTP requests. So, what happens if we make Ruby 10 times faster? In our hypothetical example, we reduce the time spent processing the request from 10 milliseconds to 1 millisecond. That's a 10 times improvement. But the total time is still dominated by waiting, and that hasn't changed. What about if we could make Ruby execution 100 times faster? Surely that's got to help. Here is the result. It should be obvious now, even if we improve the performance of Ruby, there is still so much time being wasted by waiting. So, how do we make Ruby faster? What can we do to avoid waiting so long? Let's take our example of a single request and look at it in the context of a small program. Here is our single request, and in our application, it's one of many. This kind of sequential processing happens everywhere. On clients interacting with multiple remote systems or fetching multiple records, or on an application server handling many discrete incoming requests. What if we could change this, so while we were waiting for one request to complete, we could start on another? While the latency of the individual requests cannot be changed, we can greatly reduce the total latency of all the requests together and improve the application's throughput. So, how do we build this? Let's take a look at how we need to change the code. Let's start from our sequential program. Firstly, we are going to add a worker to wrap our request so we can represent individual jobs that can run concurrently. Now, let's expand what a request looks like. First, we are going to make a connection to the service. Then we are going to write a request. Finally, we are going to read the response. Okay, let's make our read operation non-blocking. Firstly, we are going to change read to read non-block. Then we need to check the result, and if the data was not available, we will get the response wait readable. In that case, we will use a special system call io.select, which waits until the data is available. This is the operation which accounts for the waiting time in our program. Rather than waiting, we can use another special operation called yield, which passes control out of the current worker and allows another worker to execute. We also store the current worker into a waiting table indexed by the I/O we are waiting on. Finally, we implement an event loop, which waits for any I/O to become ready using io.select, and then resumes the matching worker so it can continue processing the response. Congratulations! This is the entire implementation of non-blocking event-driven I/O for Ruby. As you can see, the implementation is a bit verbose. We don't want developers to have to rewrite their code like this because it exposes a lot of details that they shouldn't need to worry about. In fact, it's my belief that you should not need to rewrite code at all. Scalability should be a property of the runtime system, not your application code. So let's rework this code and hide some of the details behind a tidy interface. Firstly, let's encapsulate the waiting list into a scheduler object. This scheduler will provide the interface required to wait on I/O and other blocking operations, including sleep. We will use it to hide all the details of the event loop and the underlying operating system. Next, let's move the details of waiting on a specific I/O into the scheduler implementation. There is already a standard method for doing this called waitReadable. This allows the scheduler to handle the scheduling of individual tasks without the user needing to explicitly yield control or manage the waiting list, as these are usually implementation-dependent details. Finally, we move the entire event loop into the scheduler implementation and replace it with a single entry point, run. Because some operating systems have very specific requirements on how this loop is implemented, putting it into the scheduler improves the flexibility of the user code to work on different platforms. As I said earlier, I don't believe we should need to rewrite existing code to take advantage of the scheduler. Other programming languages require explicit syntax, such as async await, in order to do this. But we can take advantage of Ruby's fibers to avoid this explicit syntax and hide the await in the method implementation. In our code, we expanded the read operation to become non-blocking, but this detail can be hidden within the implementation of Ruby itself. Let's revert the implementation back to the original blocking read. We still need to call into the scheduler. How can we do this? In our implementation, scheduler is a local variable. However, we introduce a new special thread local variable to store the current scheduler. The thread local variable allows us to pass the scheduler as an implicit argument to methods invoked on the same thread. The Ruby implementation of io_read is largely the same as our non-blocking implementation earlier, and internally it invokes RubyIO waitReadable. It is in this method that we add a little bit of magic. At the start of this method, we check if a thread local scheduler is set, and if it is, we defer to its implementation for wait readable. This allows all blocking I/O operations to be redirected to the scheduler if it is defined, and without any changes to application code. Finally, we have not revealed the implementation of worker. It is in fact nothing more than a Ruby fiber. While the practical implementation has a few more internal details, this is, essentially, the entire implementation of non-blocking event-driven I/O for Ruby. The original concept for this design was started in 2017, and finally in 2020, after testing the ideas extensively, we made a formal proposal for Ruby 3. This design specifies the scheduler interface, which can work across different interpreters, including CRuby, JRuby, and TruffleRuby, and how the existing blocking operations should be redirected. The actual implementation of the scheduler can be provided by different underlying implementations, which allows for great flexibility. This proposal included a working implementation for CRuby, and it was recently approved by MATS for experimentation in the master branch. This represents a great milestone for the project. We hope to iterate on the current proposal and deliver a solid implementation for Ruby 3. How do we support existing web applications? Fundamentally, the scheduler is designed to require minimal changes to application code. However, we still need to provide the model for executing application code concurrently. In addition, not all blocking operations are due to I/O. This is especially true for the current database gems, which sometimes hide the I/O operations. Even though there are challenges, because this is a very exciting development, we found existing maintainers were willing to start making the necessary improvements. For applications that want concurrency today, you can use async. The core abstraction of async is the asynchronous task, which provides fiber-based concurrency. We introduce new non-blocking event-driven wrappers with the same interface as Ruby's I/O classes. In many cases, you can inject them into existing code and things will just work without changes required. In async, tasks execute predictably from top to bottom, so no special keywords or changes to program logic is required. In the case of Ruby 2, you must use the async wrappers, but in Ruby 3, the scheduler interface allows us to hook into Ruby's blocking operations without any changes to application code. At the core of async is the non-blocking reactor, which implements the event loop. It supports a variety of blocking operations including I/O, timers, queues, and semaphores. Blocking operations yield control back to the reactor, which schedules other tasks until the operation can continue. The async gem is less than 1,000 lines of code, with good unit test coverage. We felt it was very important to reach a stable 1.0 release with a well-defined interface, along with a good test suite, because this provides a strong foundation for reliable applications. Lately, I've been looking into async, as one of my projects would really benefit from non-blocking I/O. It is really beautifully designed. Janko Moronic on the general design of async. Async has a growing ecosystem of scalable components, including support for Postgres, Redis, HTTP, and WebSockets. One of our goals is to bring high-quality implementations of common network protocols to Ruby, with a focus on both consistency and scalability. Almost all the components are tested for performance regressions. Because the Ruby 3 scheduler interface has been merged, we now have experimental support for that interface in async. Once this interface is finalized, you will be able to make existing Ruby I/O non-blocking when used within an async task. Right now, it's experimental, but we hope to release it soon. If you write existing code with async, you will not need to make any changes to see improved concurrency with Ruby 3. One of the most critical parts for many businesses using Ruby is the web application server. We built Falcon as a scalability proof of concept, and it was so successful that we've continued to develop it into a mature application server for Ruby web applications. Falcon is implemented in pure Ruby, yet in performance, it rivals other servers which have native components. This reinforces our original assumptions about the diminishing returns of improving the Ruby interpreter. Out of the box, it supports HTTP 1, HTTP 2 with zero configuration. This gives you a modern localhost development environment. It can also be used in production without Nginx. It has a really great model for WebSockets, and we recently demonstrated a single instance with 1 million active WebSocket connections. In order to reach this level of scalability, it uses 1 fiber per request, which means that your application requests will be scheduled concurrently if they do blocking operations, for example database queries, web requests, Redis, and so on. To achieve parallelism across multiple CPU cores, Falcon uses a hybrid multi-process, multi-thread model, so we can support CRuby, JRuby, and Truffle Ruby seamlessly. So, is it scalable? Well, like anything, it depends on how you use it. But in various micro benchmarks, we have shown that it can perform very well, especially when there are operations which are non-blocking with Falcon but blocking on other systems. This graph shows Puma versus Falcon. Puma plateaus at 16 workers, while Falcon is able to continue scaling up until all CPU cores are pegged. We thought this was a great result, especially if your company is dealing with a high volume of traffic. Async is the right model because web applications are almost always I/O bound. The Ruby web ecosystem is really lacking in scalability, for example WebSockets on Puma. Async unlocks the next tier of scalability in the most Ruby-like way possible. Brian Powell on migrating from Puma to Falcon. So, the big question, does it work with Rails? Yes, it's rack compatible. However, there are some caveats which we will discuss next. Active Record is a commonly used gem for accessing databases. Unfortunately, Active Record currently uses 1 connection per thread. Because of this, multiple independent fibers on the same thread will be using the same underlying connection. This can cause problems, because multiple fibers could incorrectly share a transaction. This is kind of a design fault of Active Record, and there is discussion happening right now about how we can improve the situation. I think Ruby 3 will drive these changes as the model for event-driven concurrency becomes clearer. Another issue is that database drivers don't use native Ruby I/O and are instead usually opaque C interfaces. However, the maintainer of the Postgres gem is interested to add support for non-blocking I/O. I believe we will see expanded support from other maintainers once Ruby 3 concurrency model is stabilized. These changes should percolate up into the higher level libraries and hopefully drive adoption. As an alternative, we recently started implementing a low-level database interface gem called DB. It currently provides non-blocking Postgres and MariaDB MySQL access. While we believe the existing gems may eventually adopt the event-driven model, we didn't want to wait for our own code. Redis is another commonly used system for fast access to in-memory data structures. It is commonly used for job queues, caches, and other similar tasks. We introduced a PR to support event-driven I/O in Redis RB, but unfortunately, it was rejected. So we have continued to maintain the pure Ruby async Redis, which is almost as fast as the native high Redis implementation. One important point about the async gems is that they are guaranteed to be safe in a concurrent context. In our research, we found that many gems are not thread safe, including up until recently the Redis gem. HTTP is a key protocol of the modern web. As such, we provide a gem async HTTP which has full client and server support for HTTP 1 and HTTP 2, and soon we hope HTTP 3. This gem fully supports persistent connections and HTTP 2 multiplexing in a completely transparent way. That provides great performance out of the box when combined with Falcon. We recently added support for Faraday with the async HTTP Faraday adapter, and we tried it out on several projects. The GitHub changelog generator makes many requests to GitHub to fetch the details about a project. While we didn't work on all areas of the code, we saw a significant performance improvement by fetching commits and pull requests concurrently. For bigger projects, the improvements brought about by multiplexing and persistent connections are even more significant. In another script, a traditional HTTP gem was compared to async HTTP Faraday when fetching the job status of a large build matrix from Travis. I think it was about 60 to 70 requests in total. Because those requests could be multiplexed on a single connection, the overhead was significantly reduced. Rather than making a large number of requests sequentially, all the requests could be made on a single connection. It's these kinds of results that make me personally really excited about the future of async, Falcon, and non-blocking event-driven Ruby. As a bit of fun, I found this interesting experiment with the FFI gem, which we use for implementing the DB drivers. It moves FFI calls to a background thread, and then yields control back to the scheduler. While it's pretty risky in general, in some cases this can be a valid approach, and offloads otherwise blocking C functions to background threads. So, what are the next steps? It depends on you. The community. Please try these new gems and features of Ruby and give feedback. The best thing you can do is have fun with these new projects. I hope they make scalability exciting. And the businesses. Please support this important work. We recently introduced a paid model for Falcon. If you are interested in this, please reach out. We want to support the Ruby ecosystem and help it continue to grow, especially in relation to scalability. If this is important for your business, you can help us develop it further by investing financially. Thank you for listening to my talk.
Hi everyone. I'm going to talk about Road to RubyCop 1.0 today. My name is Koichi Ito from ESM Inc. AWA System Management. On the internet, I use @koik as my name. As one of the core team member of RubyCop and also as an open source programmer, I am doing something such as giving this kind of tech talk. During the day, I work at AWA System Inc. as a distinguished engineer. My company, AWA System Management, is a company focusing on contract-based system development. If you have any offers or if you are interested in working with us, doors always open. Please contact us. I also work with OSS community. Every month, I organize OSS patch meeting with Matsuda-san, who is the RubyKaigi organizer. This is a public event, so please join us. Today, I am going to talk about RubyCop. It is a static analytic tool for Ruby. It detects code with bug, or it can create format that works well for the teams. Last year at RubyKaigi 2019, DRECOM conducted a survey asking everyone what is the gem to install first other than Rails. RubyCop came out as number 4 in terms of gem download, so I guess RubyCop is used quite a lot within Ruby community. Recently, RubyCop downloaded exceeded 100 million downloads. It's a good news for us. There are 8 RubyCop core developers in the world. RubyCop development started around 8 years ago, according to the Git log. It was developed by Bozidar from Bulgaria. There are more than 700 contributors, and every day something is happening. So RubyCop project is very active. I became active around 4 years ago. Have been RubyCop committer since RubyKaigi 2018. From a Ruby committer's point of view, I would like to talk about changes for RubyCop 1.0 along with RubyCop architecture. The current RubyCop version is 0.89.1. This is the architecture stack for RubyCop after version 0.84. Let me talk about each layer. Let me talk about the top layer, custom cop layer first. RubyCop HQ is a custom cop layer managed by RubyCop Development Project. This includes RSpec, Performance, Rails, Niltest, and Lake. Performance and Rails are isolated from main RubyCop core. The past architecture looked like this before RubyCop 0.67, and it was the only major custom cop used by RubyCop RSpec or RubyCop Core. There are other ones besides RSpec that can be isolated from RubyCop Core. First, we extracted performance cops into separate gem. This was opened up as one of the milestones for RubyCop 1.0 by Bozidar. It is now positioned the same as RubyCop RSpec to be outside RubyCop Core. As gem, we keep the name RubyCop Performance. RubyCop Performance collects cops that focus on speed. It suggests faster method, if any. This one is document. Besides bad case and good case, it shows some reference. For example, this reference is shown as basis for cop. In performance, you often see Finito Fast Ruby repository. You see benchmark, and sometimes there are additional references. When you track the source, you see that it was based on the actual example of Rails position, as you can see from this slide. I personally think this is a good public use case. Let's run some sample code written by FastRuby. With Ruby 2.7.1, if you use proposed cop, you can accelerate the speed by 5 times. These are the Gemify nodes when performance cop is extracted. RubyCop should focus on Ruby language itself. So performance dependent on Ruby processing needed to be isolated from core. RubyCop supports JRuby, but RubyCop performance itself is based upon MRI performance, therefore processing dependent. As for RubyCop source code, we have separate directories for each role, like length, style, layout. This time, we wanted to extract performance directory. How would you gemify first? CP command can be used to copy from the RubyCop core source. You can think about that idea. This is quick, but it removes Git history. this is quite painful. When you have a problem, you need to find out why that particular change was made. But if that information is missing, then it becomes quite painful. So this is quite an issue. If it is a project maintained for a long time, you see more changes along the way. Sometimes you need to refer to Git to find out. So this is quite an important matter. I personally think it is better to appreciate the contribution made by each committers. So I made sure to keep the names of contributors. In the past, Matsuda-san made Kaminari, a pagination gem, and I knew he isolated rendering engines. On the way home from Asakusa RB event, I asked Matsuda-san how he left it on GitLog. His answer was really simple. He used Git cherry pick as much as he could, like dozens of times. I got the answer I expected. So I decided to do the same. There is an empty RubyCop performance that's been prepared remotely. It is quite difficult to make third-party custom cop from scratch because we needed some reference on what to do with RubyCop extension point. It was difficult to make it without some examples. So we referred to RubyCop RSpec structure. And then we brought it from RubyCop core, the source. And after that, all I did was cherry pick, cherry pick, cherry pick. I investigated hash value within product code and test code by looking at Git log. I kept repeating the process. When I'm done, I push it to RubyCop performance, and that's it. How many times did I run cherry pick? Including the later mentioned RubyCop Rails, I ran about 500 times. I needed to do it over sometimes, so it was more than 500 times, I guess. It cannot be made in one day. I spent days or months whenever I felt like it. I used cherry pick the most during that period in my life. There may be a better way to do this, so if you want to gemify this in the future, you may be able to find something better. That's all on performance. Next, we gemified RubyCop Rails. This was one of RubyCop 1.0 milestones. This is RubyGem. RubyCop core focuses on Ruby. So we didn't want it to support peripherals, such as framework or libraries. We wanted to resolve some issues by being dependent on Rack, but it was difficult to incorporate that onto RubyCop core. This time, it is isolated to RubyCop Rails. Since it is already Rails dependent, so RubyCop Rails now also depends on RackGem. It was gemified in RubyCop 0.72. The first RubyCop Rails started from beta version 2.0. This is because of the namespace problem. With Ruby gems, you can only name #1 ranking name for gems, but RubyCop Rails already existed to gemify .rubicop.yaml in Rails/Rails repository. Around RubyKaigi 2018, YA Honda from Oracle Enhanced Adapter and also Bojidar had some discussion. Also, at the time of RubyCop Rails 1.0, I talked with the owner Toshimaru-san, and he later gave us the name. So please note, RubyCop Rails version 1 and version 2 is completely different. RubyCop Rails version 1 is being renamed to RubyCop Rails config. RubyCop Rails version 2 extracted Rails cop from RubyCop core. Let's talk about RubyCop Rails future plans. It works on Rails 4.2 right now, but in the future, RubyCop Rails 3 will drop Rails 4.2 support. we are not proactively supporting Rails 4.2 right now, so there are no new feature acceptance for Rails 4.2. Unless there is a serious bug, we will not make huge changes. We hope to update Rails itself. So far, I talked about custom cop as a RubyCop developer. User can also create new custom cop. Gem called RubyCop extension generator made by Pokke-san will be useful for that purpose. This gem generates directly structure for your gem. Since RubyCop itself is not yet stable and API is not yet provided, it also works as plugin, and that is not ready. This gem contains monkey patch code as well. This is the result of commands execution. As you can see, directory you need can be created this way. Even when there's monkey patch or code with bad know-hows, these can be handled as a file. When you do your search, looking for some information, you can skip some cumbersome processes. When do we create third-party RubyCop gem? RubyCop handles general Ruby-related issues. RubyCop Rails handle general Rails-related issues. I think specific gem issues, anything specific to individuals or projects, such domain experts can create gem and do the maintenance. For example, this issue was opened on RubyCop Rails. There are 3 pull requests regarding Rails engine. It was about always specifying namespace for module underneath Rails app/models. The idea seemed to work well within the company of the requesters, but it was a bit difficult to support this on general Rails application, so I suggested to gemify this as Rails engine-specific gem. A company called Flexport Engineering made the gem and made it public on its blog. I think this is a great example. Let me now talk about some changes made for version 1. It is regarding the API used in case you make your own app, own cop. This is relatively a new change made based upon RubyCop pull request 7868. This is the change. The cop shows the previous code, the bottom shows the new code. If you make custom cop, you don't succeed cop, but succeed base. So far, code for autocorrection required to define autocorrect method. But for the future, you can extend autocollector module and use add offense method to write the process. You can reduce overlap node processing. You can reduce code redundancy. As a side effect, autocorrect can accelerate the speed. Old API to succeed cop class will not go away soon. But it is a soft replication, so I strongly recommended you to use cop base. RubyCop core is migrating still, and it is very new API. So we may find some problems in the future. If you do, please open issues.
So this new API and migration, there is an upgrade node as for the public documentation, so please issue that. And then RubyCop AFT media layer is what I'd like to talk about. This is a change made over .83 to .84 of RubyCop, and this would be a third gem which were carved out from the core. ASP is slightly different from the one that I introduced. It is not related directly to the end user. The Gojeda tool has the RubyCop node pattern function, and you might want to utilize. Therefore, we carved it out. In reality, there is a bug detection tool or CLR tool, but they raised such request. And here, I would like to introduce some APIs. This is the ASP node pattern. This is a unique pattern match laid over to the Ruby's structure model. For example, plus stage node or method call node, either one is matched that can be expressed, or maybe the captured value out of the argument can be utilized. Death node matcher API scheme often use this. Robocop AST node is a Robocop's dependent parser gem. I will talk this about later, but that parser expression node object expansion API is also provided. What can we do with this Robocop AFP? We'd like to look at this with a JS code. And we hand this over as a text string. This is the second version Ruby. And ASP method is called, and ASP is here. And ASP object is a gems node to reflect. Usually this shows the strings node. And by question whether that is matching, whether it's mode or not, but hello, integer float.nil, literal or basic literal or not, will be judged by this method. And ASP, what kind of process is done? Robocop AST traversal API is here. Robocop AST traversal is included, and onSend method is defined. AST processing targeting type is matched to with onSomething methodology. That will be a callback method. Walk, if we hand it over to the previous node, we will execute the onSend. The robocode itself has this functionality, and past AST will be called with a callback, and then detects the offense or automatic correction is done. And this Robocop AST, if we have this gem pre-built, it will be good. So this is a Robocop extracted gem. And a similar tool, if you are interested in similar one, please leverage this. I think Robocop itself would be a good reference. Now we'd like to dive into the bottom layers. This is not developed by Robocop, but this is repository. The white plan is the one of the base. AST object is created by this gem Robocop AST, and other one like Opal or new Ruby version or Ruby or Ruby Next transfer also is using this. Parser gem is a parser written by Ruby gems, and I checked this earlier, but MRI, JRB, and Truffle Ruby is also supporting. BNF is the core parser, and it is written by RUB. New Ruby syntax introduced in parser as experimental. And then for this new installation, Robocop AST extends parser's new API, and then CUP can handle new syntax tree node to a random height assignment and assign method definement also in the parser. How parser will follow Ruby and trace. The parser maintenance, Opal chain Mediasan is aggressively doing this, and Ruby parser change is being issued by him. And others repository can be locked by himself. This is Tsujimoto-san's pattern match change is defined, and this is the result. And the test code is here. Hash pattern, hash value, end with comma. That is checked. Pass line is here, and key by arg is followed by comma added change with comma or without comma, same installment. And this request is an example. Parser test code is written with Ruby. Pattern match in is handed over, and we have the comma added. Parser chain DMF has the comma here as well, and the behavior is the same as without comma. That is the only change. Parser gem install case, Ruby pass command will become usable, and AST can be checked with the S formula. And to your left is the comma, and to your right is without comma. So parser Ruby syntax analysis can be traced. So this is the architecture around Robocop 1.0. Now I'd like to look into the Robocop core itself. Recently, Robocop core made some major changes, so let me pick them up. Safe and safe autocorrect. Here, Robocop 1.0 milestone. So what are safe and unsafe? RubyCop is a static analytic tool, and runtime info is not available. So false positive detection may happen, and incompatible autocorrection may happen. So RubyCop default should be utilized as a sample. Safe autocorrect is RubyCop YAML set by RubyCop, and default is true, so default is safe. If it is not safe, set as false. So in case of safe, the definition is to indicate whether the cop can yield false positive or not. And there are several cases. This is a bad case, good case difference. The good case is faster. However, I would prefer the readability rather than the speed. However, since this focused onto the performance, so we merged. Ancestor's method has sometimes it detects or false positive may not be that important. So there is an issue. Eugene, Redis committer, found the false positive, and RubyCop static analysis says that the receiver may not be able to find it out. So that is a difficulty. So Redis application shows the active record and plain old frequent false positive due to the difference between the active record and this. Next, safe autocorrect. This indicates whether the autocorrect cop does it safe by design or not. If safe false is set, then safe autocorrect false is also set. I think that is quite reasonable. Example 2, performance start with cop equal till start with is easier to use. And false positive is not so worried, but error if the variable is nil, you can be avoided by adding a safe navigation operator, but it is not always right. So safe or correct is set as false. So with the cop in mind, safe navigation operator default alternative option should be offered. Next sample. Rails cop plug unique. This is to be changed to unique before plug. So Ruby unique would be, I think it will be more effective. Our BDMS setting, compatibility is not guaranteed between Ruby's unique method and our VM distinct. And that's quite understandable as well. And if this is not safe, Ruby 2020 introduced this unique case. Kotte-san developed RubyCode tile library, NP3 implementation style type. And this is work in progress, so we look forward to his development going forward. Now, safe, correct usage is what I would like to talk about now. RubyCode commands has offers a safe option, and RubyCode option is run under unsafe state. And please -safe for the safe environment as well. Apply only safe autocorrection with this option. And at 86, this was a target for unsafe state as well, so please be careful. And first, the literal command is not applicable. And large A, this is applicable to the unsafe and safe as well. And for the next, with the upgrade, new cop status will be added, so there may be some issue. And RubyCode 1.0 or instrument is one of the case. New cop status is the status starts with a pending. And this is disabled unless you set this. And all pending cops are enabled when the major version bumps. So either user make it usable or unusable. And all the pending ones will become usable. Or if you want to enable it, please give us a feedback. And this is a recent topic. RubyCop support Ruby version. Up till now, Ruby UOL was for 1 year, but make it official. By dropping this, RubyCop Jam will change the support scope. So support period margin should be an official period now. But after EOL is not really officially supported, so I think it is better to update the Ruby to the latest version. So 3.2.4 will be supported by RubyCorp until next spring. But for experimental reason, we will support. And custom COPS layer will have the configuration layer on top of it, and RubyCorp default set the user customization. Noted one is a text string or dot code, which you prefer. That will be an issue, but .robocop.yaml will offer the customization. Please refer to the robocop.org for the details, and GitHub and social coding is the area where we can meet. So I wish the world will become happy place again so that we can meet again to have the RubyKaigi. Thank you very much for your attention. Hello, this is Seki. Today, I'm going to present a case study of an embedded system using RINA. So I'm going to introduce myself. Let me introduce my book. The usual red book. You can still buy it. I just looked at Amazon, and this is the last book I could find, so you might want to hurry. And the English version of this was published by Light Magic. It already out of print in 2014, but we've republished on the web, so you may want to read it. And this year, 2020, I wrote an article for Ramada Note magazine. It includes comments that is relevant to today's story. Yes, I am a Ruby committer as well. I am in charge of ERB DRuby of Linda. The L Linda is a language for parallelism, an emphasis language. We use tuple space and file distributed shared memory to exchange tuples, and it's something that allows you to coordinate multiple processes. The R Linda is a Ruby implementation of this Linda. Let's say you have multiple processes. Now, they are processes. The processes communicate by sending each other the data called tuples. However, processes do not directly exchange tuples with each other. Tuple space is a place to put tuples. Processes exchange tuples through the tuple space. If the desired tuple is not there, it blocks until the tuple is placed. This can be used to achieve the rendezvous. Here's a textbook on tuple space. It's a very good book on how to create parallel programs. This is a book written by the people who developed the original Linda. Today, this Ruby version of our Linda is what I would like to introduce to you. Even though it's an emulet, it is not a text embedding feature like ERB. It's more of an embedded system that controls the device. So what we are going to talk about is a robot telescope. This case study is not the system that I had developed, but the system developed by Mr. Yanagisawa at National Astronomical Observatory of Japan. Today I'm going to cite two documentations from him. The detailed explanation of the robotics telescope, please read these documents. I learned about this robot telescope from Yanagisawa-san, who asked me about the question when I was preparing myself the first paper. So I'm not an expert, so probably I will not be able to explain well, but everybody please bear with me. All right, let's see. So what is your image of a robotics telescope? Imagine it for a moment. This is amazing. This is an exterior. It's probably a lot bigger than your imagination. I was surprised when I first saw it too. It's a wide-field near-infrared camera with the second largest market share in the world. There are very few unmanned near-infrared robotics telescopes in the world, and it's only the third in the history to do this. They have one of the fastest engineering in the near-infrared. And then I have a bit of problem with my hypothesis, so from now on, I will simply going to focus on the camera. This camera is modified version of the Okayama Astrophysical Observatory's 91 centimeter reflecting telescope built in 1959 by what is now Nikon. I think you can get this image of the size of this camera comparing the light track. The goal of this camera is to leverage the diffraction of elucidate the structure of the galaxy disk. This is a probe of galactic structure. This is an ideal one. The purpose of the camera is to probe for that diffraction. According to the 2017 data, the camera has found about 90 candidates for the Cepheid diffractions. Note that this is the only camera that can monitor the survey, the galactic plane for the northern sky. Isn't it amazing? The only one controlling this amazing robotics telescope is Ruby and Linda. Then I am going to talk about this control, how to become autonomous. We will talk about the overall coordinated operation, and then I will talk about the individual control first. I will talk about the astronomical monitoring and autofocus, and then discuss overall narrow operation. Weather monitoring. The weather monitor is a feature that monitors the weather conditions and can automatically stop the observation. It used a device called mid-infrared cloud monitor to look at the radiant temperature of the ground and the radiant temperature in the sky. The cloud that is made in the rain are not so high up on the ground and warm, so we are going to look at the temperature difference in the sky relative to the temperature on the ground will be small.
With appropriate threshold, the system can make a judgment whether the sky is cloudy. Above a certain threshold, dome shutter is closed and observation is discontinued. Autofocus consists of two different mechanisms. First of all, the length change of the tube of the telescope is measured, and it is used to move the position of the secondary mirror. Distance sensor is established. Parallel image is checked every 10 minutes, and this information is used to reposition the secondary mirror. Next, I would like to talk about the overall configuration. On this slide, you can see the hardware block diagram. It may be too small for you to see, but all of the different equipment and devices are connected via LAN. There are about 14 different control elements, including equatorial mount, dome shutter, and a dome rotator. Each of them are allocated with a specific controller, and the controller has I/O to the board, which was made at this venue, and it is controlled through serial communication. Each controller connects to LAN via PC or terminal server. On this slide, you can see the software block diagram. In the center, you find Rinder tuple space, which is distributed shared memory. Each process watches out for different tuple spaces, and once an instruction is given, controller checks it and the result is written into the tuple. Some processes just report the status. For example, weather is used to write information about clouds.
and that's all it does. Next, I would like to talk about different movements and sequences. Daemon, controlling dome shutter, is monitoring weather dB, and once the cloud thickens, it writes an instruction to close or open the dome. This is the image capture. Scheduler would write a queue with the acquisition method as tuple, and monitoring daemon will receive it. And if the weather allows the monitoring, it writes a tuple to open the dome and change the attitude of the mount. And mount control daemon will receive the completion of the process using another tuple, and the next instruction is written. This is a chain of tuples, and for this camera, all the time 300 different tuples exist. Tuple write, read, and take. These are simple operations that are used in Rinda in order to share the project. But there are some concerns. If the process is unstable, for example, if the measurement device fails to measure or fails, or if there is a restart, number of tuples may not match and synchronization may be failing. We need a mechanism that works even when we cannot trust the number of tuples. In this camera, the following strategy was employed. For monitoring, tuple with timeout was used, and notify was used instead of take. Tuple with timeout and notify, these are functions which do not exist in the original tuple space, and I personally added them when our Rinda was created. Using this mechanism, tuple always has the latest information. When there is something abnormal, then you will find that the number of tuples is 0, and you get to notice that there is something going wrong. This is an example of weather monitor. Weather monitoring equipment writes the result every minute, and monitoring result tuples live for 2 minutes. Control process will wait for the result on notify, so the number of tuples do not reduce. If everything's working normally, 1 or 2 weather monitoring result tuples exist in the tuple space. If the weather monitoring equipment fails, there is 0 tuple, so you get to notice that there is something going wrong. This camera has been designed to be able to be used in the actual practice and operation. And this is a summary of the report. Quote from the site written by Yanagisawa-san. Unmanned monitoring has weather judgment function and autofocus, as well as a coordination of the various devices. And sitting at the center of the software, we have Ruby and Rinda. It's great, really impressive. Actually, we had another example, and I'm hoping to be able to share this example at the Ruby meeting in Tochigi next week. Thank you for your attention. That's it from me.
左、左。逆じゃない？逆。名前が逆。
あ、本当だ。
すごい便利。
あ、そうなんですか。すでに。
あれるのやめなきゃ。こんにちは。
Hi, everyone. Without us knowing, things been already started. So I guess you can see the screen we've shared. So can you see us? Can you see the screen? I have to check the YouTube. Well, I see it. Move on. Slides are up. Move on. I see your face. We see your slides. Let's begin. Rivik Commuter versus the world. Welcome. Other than usual, rather than us standing on stage looking at your faces, well, we wouldn't know if you're sleeping while we're talking. But let's just get going. RubyKaigi. Ruby committers are coming on stage usually, and this is done virtually this time. And my name is Sasada from Cookpad. There are a couple of announcements we would like to cover, and also we would like to cover Ruby 3 related topics as well. Today and tomorrow we have sessions, and tomorrow we're going to talk about static checking first, but we are hoping to cover all the other topics today. First, announcement. Shugo Maeda speaking. Shugo-san, the floor is yours. I would like to take this opportunity to share report with everyone, news with everyone. I'm sure some of you already know about this news, but last year on August 28th, Ruby committer Hashimoto-san passed away. Since then, this is our first RubyKaigi since his passing. So I would like to just share this news with everybody. Well, I was his boss at work. So on behalf of the committer, I would like to share this news with everyone. Hashimoto-san was working on the Ruby Japanese documentation. So he became a committer to give us the feedback related to errors on documentation. And also in Shimane, there's Matsue Ruby, the local community, and he's been contributing a lot. He was contributing a lot as a committer. So he passed away on August 28th last year. So it's been almost a year since his passing. So I would like to take this opportunity again to wish for his soul rest in peace. Okay, floor is back to you, Sasada-san. Shugo-san, thank you very much. Last year, he was so young and he passed away. So Ruby members were shocked by his passing. And I still remember that very clearly. May his soul rest in peace. Let's move on to the next topic. Do you want to talk about something, Endo-san? Sure. Ruby CI org. This is the service collecting all the results of Ruby CI. Well, this was originally CI created by Akea-san, and then Naruse-san launched it as a service, and then everybody's maintaining this. So lots of companies are involved, paying us money, and that's how we are maintaining the economy side. We're very thankful for the support. So we're just very thankful for your contribution. So when we run CI, we need money. So you're extending support to us financially. And if any companies interested in funding us. We have Ruby Association in Japan looking for co-sponsors, and we can pay for servers. So we cordially ask you to join us to be the co-sponsor. I am the director, and that's why I call myself as director marketing. And also, other acknowledgements are described here for full-time Ruby committers, full-time open source developer being supported, and there's so many companies listed, and MRI, C Ruby development being fully committed by these companies listed here. Matsumoto-san, Endo-san, myself, we belong to Network Applied Communication Lab, Cookpad, Money Forward. I'm sure you know these names, but there are other companies joining us as full-time Ruby committers. So let me introduce the newcomers. You see the question marks here? Could you explain? Sure. Can you hear my voice? Yes, we can. My name is Nakada. I belong to Akatsuki. I've been doing the same thing as before, full-time development. But on top of full-time development work, this year in May, I haven't been to the company yet. Good to meet you all. Well, I think you should introduce yourself personally, but talk about the company as well, maybe? Our company is focusing on entertainment field. Hope we can enjoy all together. Shopify. From Shopify, extremely fast-growing company on EC field using Ruby. And 2 members from Shopify are joining us. And as announced, for Ruby, there are so many contributions made by the 2 members. That's all from us. Aaron-san. Aaron? Well, we apologize. That's the wrong name calling, but or just the wrong pronunciation. But anyway, last year we had Ruby event, and then there are new committers listed here. Jeremy, Sotaro, Alan Wu, and Bardet. I cannot read it out, but these are the new committer members.
Yes. Hello, everyone. My name is Jeremy Evans, and I became a committer shortly after last year's RubyKaigi. Since becoming a committer, I've handled the separation of keyword arguments from positional arguments, and I've been going through Ruby's bug tracker and triaging and fixing bugs. So in the last year, we've gone from over 1,400 open bugs to under 400 open bugs, so a decrease of over 1,000. I hope to keep working on bug triaging and bug fixing in the future. Thank you.
So he's deeply committed to our activity. We can't believe that he's new to this committer's world, but according to him, he's still a new committer. And Sotaro-san, could you give us a comment? Sotaro-san, are you here? He said that he might not be able to join us today. Since he is not here, maybe we might ask him to greet again tomorrow. Ruby track changes. Chikanaga-san, Mr. Nagachika-san, he tweeted that it has been 10 years. So we would like to celebrate his 10th anniversary. Congratulations.
So it will continue a bit more. And so as you continue your effort, could you introduce yourself? Yes, it has been a decade already. I didn't believe that I could continue on for 10 years, but I think probably around 20 days is a max that I didn't commit to this activity. So rest of the time frame I have committed very actively. So I am amazed how this development has been continuing. So my word saying that it will continue a bit. It is from an episode of the Dragon Ball. One of the person would say that, and that is this series will continue as Dragon Ball. So as long as this series does not make any big change, I would like to continue to commit to this development. Thank you. Can you name some major commitment you did recently? Yesterday, Raptor. Any other commitment that you can name? Well, I might touch upon this later, but one line method definition or the right assignment is what I am interested in. So maybe we can touch upon those later. So today's topic. Thank you very much, Takanaga-san. So these are today's topic, which will be mainly talking about Ruby 3, JIT compilation and static checking and concurrency parallel executions. Those are the three targets of the Ruby 3, which Matt-san probably in 2014 mentioned, yes, I think. Matt-san, please keep your microphone on. And we were wondering who would take the responsibility, and I thought Matsumoto-san said that he would do it. But initially, the movement wasn't really fast. But as mentioned earlier, static checking topic and JIT compiler, which was not discussed today, but also Raptor and Samir's Fiverr scheduler. In order to materialize those, we have been committing for the development to date. So Ruby 3, we had the major upgrade recently at the developers committee, and Matt's discuss in such committee, but it just happened in that meeting and we upgraded. Yes, in the mid of that meeting, yes, we pushed. We were wondering whether to introduce it or not, but Ruby 3 is 3 times faster. That has been a target. And we would like to verify whether the Ruby 3 is 3 times faster or not. I think many of you are interested. So before we talk about that acceleration, we would like to talk about JIT. So I didn't have time to put together my presentation, and I only have this one slide, but Ruby 3.0, I made this development around JIT. Method inlining, application scope was expanded. So C-written method is quite difficult. The definition is difficult. So we wrote with Ruby, and C method behavior should be annotated so that inlining could be applied. That is what is ongoing. And through this, compiler would check what is coming in advance, and then the return is automatically returned. And the second is a JIT. What I'd like to solve is acceleration speed and the Rails as well. So the JIT compiler number would be, if that is increasing, the speed will be deteriorating. So that development is where I'm spending most of my time. So the code, creation code,
So by today, method-based code was copied, and now we are able to share that. So microarchitecture-wise, the speed was accelerated. And lastly, it is for the instance access number. In C method, if there are multiple ones, the plus check can be merged. And that is how we achieve the faster inline variable access. So the difference from the 2.7 to 3.0 improvement was what you discussed. Yes. So, and that's the last bullet. Ruby 3.0, 2.4 faster is extended to 2.7 times faster, but we have not reached to 3.3 times faster. Well, approximately 3 times already, right? Yes. If we round it, it's 3 times faster. 3.0. Rails application, we need to sustain that speed as well, because you would use Rails application in normal days. So it's impossible to make the 3 times faster. So I think given that environment, I think this is a fair statement that we are achieving this level. So Rails application, I'd like to improve, and also VM-based run needs to be accelerated as well. So Go AI writer, the developer, also demonstrated that it is faster.
And sometimes you see ups and downs. This is the difference in terms of speed against master. And every day through commit, sometime release by 1/3, performance being hit. This happened. And sometime the VM was running slow, but instance variable. Well, we're just trying hard to improve the situation. Once Rakdo comes in, you see the drop, but we can make some improvements on that as well. Thank you very much. With Ruby 3, we asked the committer what's their favorites in terms of features. And Matsumoto-san came up with pattern matching as his favorite. Any comment, Mats? Well, pattern matching? This is something I wanted for quite some time, but Tsujimoto-san gave a great proposal and it made sense to me, and that's why we were able to support pattern matching now. This is something I wanted for a long time. Before Ruby 2.0 release, I really wanted it, but we couldn't come up with the right grammar. So there was no good proposal. So I just kept it in my mind, but now it's coming to true. So it's a good news for me. So far there was a warning, experimental, but no more warning. So that means it's official, right? Correct. Mats, I think you also suggested write assignments as your favorite, right? Well, this is my favorite, but it's not that popular among others. Well, tomorrow's keynote recorded, I passionately talk about the right assignment. You might see my passion slightly there tomorrow. So I hope you can be convinced how good this is. So right assignment. Any others who like right assignment features? 0? No one? Well, I like right assignment myself. I support it too. I don't hate right assignment. So pipeline ender, well, arrow, method, receiver, combined together. Sometime that might work well, right? Yes. Pipeline, I gave up on pipeline this year. So maybe it might come back in the future. I don't really know. Endless method definition. That's in as well. This is how it can be described. Anyone who passionately want to talk about this? Well, this has parentheses. Even though it's empty, you need parentheses, right? Yes. Right now, yes. Well, we were talking about getting rid of that, but it's still in. you do need a parenthesis right now. Well, on April Fool, this is something that came in on April Fool. Any comments? So this was proposed on April Fool, right? That's what you meant. So people say Ruby is ended, but we tried to offer endless Ruby method to counter that idea on April Fool. Well, because some people talk about ending Ruby,
endless.
end of Ruby. So in the past, well, Nakata-san, well, Gorubi came in. Well, that's not April Fool. That's done when you had free time. Well, just before 1.1 release, everybody was so busy, and then somebody just sneaked this in. And somebody got excited and they wanted to sneak this feature in. Was that the get-together, like sleepover event? No, that was sneaked in on December 23rd, I think. So it was really a sneaky one to be inserted, and we didn't have time to be deleted. So another noteworthy one is module include semantic being changed with Ruby 3. Well, for the included modules, so when you include that module, then the class included, now you can insert it, meaning that it gives a big impact. But not many people are paying attention because it's a minor change. The other one is keyword parameters. Since 2.7, the migration path being worked out, and Jeremy, Endo-san, Matsumoto-san, all these members had discussion on this. And it's based upon 2.7 guidance, right? Mats, any comments? Keyword parameter is based upon 2.7. So you're going ahead with 2.7 direction to separate the keyword parameters, correct? 2.7, we had some challenges and we asked around people and we identified the problem. And warning is too annoying, some people say. So with regards to warning, we made some adjustment and everything is as planned. This is Nagachika. With regards to warning, 7272, we can contain the warning as well. That's our plan. Just a note. So 271, everyone was annoyed with warning. So 272, you got rid of that warning. That's our plan. We are planning to get rid of it with 272. And still, and I think we're almost finished with the discussion, but replication, warning policy, deprecation warning policy is going to be going soon, but it's disabled by default. It's another change. Anyone want to add information? AKR? AKR, are you there? Yes, I'm here. Well, before 2.7 release, deprecation warning should not be shown on default, by default. That was my proposal, but unfortunately, my proposal was rejected. And then after a year, everybody understood what I meant. So it's good. It's quite impressive. Are we okay on that? This is a difficult one. How much we show. I think we had lots of discussion on this topic. So warning, and we also have some categories. Since 2.7 release, we had more discussions, but I think it's really difficult to handle the warning.
Yes, that's right. And we got some comment that it should be on. However, if you designer that, and you can have it. And before we have new Ruby, let's check duplication warning. This is something developers should keep in mind. If users do not know about Ruby and they run away from Ruby, that's the worst, but they're getting learning is better than that. And we are changing that for the 3.0, and there was the changes in Rush, so we are having 5 minutes remaining. How's that class?
そうですね。僕からすると晴天の霹靂という感じで、僕自身はそんなに推進する気はあまりなかったんですけど、なんか一部リテラルを入れようとかそういうとこ盛り上がっていて、それ以外にも前々から性能の改善とかいろいろありまして、そのあたりずっと放置してきたこともあったんですけど、意外とセットを好きな人が多いということが分かったので、そこにちゃんと労力を注ぎ込んでいいものにしていこうという方向になったのは良かったと思います。ただリテラルについては今後もちょっと議論の余地はあるかなと思っているので、その辺興味のある方はチケットにコメントしたりとか、RubyJP とかいろいろスラックとかコミュニティもありますし、Twitter もあるのでコメント寄せていただければと思います。
I welcome your opinions on it. So, were there many people who wanted to have that?
少なくともコアに情熱のある人が2人3人いるっていうのは可視化されました、ね。
2 or 3 passionate people.
なんか
If you have any comment or request, please speak up. Regarding set literal and JavaScript key hash, these two are conflicting. So if you have any preference which is better for you, and if you can speak about that, that would be great. And normally, if you have bigger voice, your opinion will be hard, so it's better to speak up. Can I merge Lacto to master? We have merged this. Okay. What if I say we shouldn't have it? Would you delete that? What do you mean? What if I say Lacto is not good? Because the question is, can I merge Lacto? So what if I say you can't? If there's a big bug, probably that's a different story. Yes, it seems that there are many bugs. I will fix those. We have 2 minutes remaining. So we would like to have aisle 5. Rakta send. Okay. There's some discussion on it. And Kamizono-san has some comment on the slide, but the 2 minutes is not enough to talk about this. .flows, please. Sasada-san probably can optimize this. Okay. May I? It's Matsuda speaking. If there's the time to do this, I would like to have this implemented on 3.0. And when you say you cannot do this, I'm not sure how difficult it was to implement this.
あれ入れたらなんか互換性で問題があって結構やばそうな報告があってなんかリバートしたような記憶がありますけど。
Interchangeability, and that is why we took it out. When you say it seems there was a problem, I think you have to
clarify or specify what kind of problem that you had. If you say we will not be able to put it because it was the end of the year, that's understandable, but I'm quite disappointed because you said you couldn't have it at this point of the year. We have to check the log, otherwise I cannot make any comment on it. Not only literal, but that you want to use it for 2S.
これ、
So
16150っぽいので URL 貼っときました。
I am now attaching the URL for this
こ
16150.
の Zoom のチャットに。
So when you say there's a problem with the performance, what kind of usage did you actually have? The URL framework, active record, template engine, and log? And there are lots of the symbols written on layers, and it was translated into that, and we had about 10,000 strings. So it's not literal. Some literals on templates were used. Can you check the group chat right now? No. Now the time, it seems that we are reaching the end of the time. Okay, at least we've heard that which topics should be revisited. Probably it's better to have another session of this. But I heard that Shopify already uses this one. Every month, the 5 hours we use this. Maths didn't come to that, and we couldn't make any decision making for the detailed the specifications. Okay, it's for today. It's all for today, and tomorrow we are starting from 10 a.m. But we can continue this session if you want. Committees, please do not leave. So tomorrow at 10 o'clock, we will open up. And if 10:05, we will start this one. So for now, we would like to close this session, but I hear that we can continue using this room. So please stay in this room, hand it over to Mats, and then we can return. I'm not sure what I should do, but please continue on. So thank you very much, everybody.
関さん来た？まだ来てない？
2S dot please. Optimization, I thought that was interesting, but we can do it, right? Yes, we can. But whether we freeze it or not is unknown, right? 2S dot. On rail side, we make that way, right? So if we are doing something to hash 2S dot freeze, we can change your name. If everybody can agree on that one, yes, that would be good. To s.freeze should be renamed to something else. That would be the optimization. So both end, if the both end have not been optimized, we should shortcut. Well, I think it's easier to make one shortcut.
To frozen S みたいな。
The different method name would be better. To for raise freeze dot strip. So from Rave's standpoint, I guess they don't have any disagreement. Dot name, I think it's simple and good. If you narrow it to the symbol, we are not sure how they are using it, so symbol should be the one to make things run. Yes, I think that sounds good. Module name. Template engine needs to run with the 2S. That has to be accepted. I think it's a separate. So string, I think we can talk about the same. The number, 2s.freeze. Thank you very much. This is the end of the translation service. Thank you.
To FS どうぞ。